If you're preparing for GCSE Higher Maths, then this is the video that's going to make the biggest difference to your grades. I've written a huge past paper with 106 different questions, and it covers every single topic in the course. And in this video, I'm going to go through the solutions to all of those questions. You can find a link to this paper in the video's description. The best way to approach this is to try each of the questions yourself first, and then come back to the video to mark them. You'll find that you get some of them right, and some of them you get wrong, and it's those that you can revise in more detail. I've even put a checklist of all of the topics at the front of the paper so you can keep track of your progress. To complete the paper fully, you're going to need all of these bits of equipment: a pencil, a ruler, a pen, a pair of compasses, and a scientific calculator. When you go through the paper, you'll see this symbol. If you do see this symbol by a question, then this is a paper 1 topic, in which case you shouldn't use a calculator for that question. And before we begin, a brief disclaimer. Just watching this video is not enough to guarantee you're going to pass your exams. There are many videos on YouTube with people claiming you can pass your exams with a couple of hours of preparation, but this is just not the case. If this were the case, we'd just shut down schools and everybody could learn everything from YouTube. This is of course an incredible resource, but you need to practice the topics that you struggle in more detail after. In addition, whilst all of the topics are featured in this video, not all of the variations are. Most of the topics in the GCSE Maths course can be asked in a variety of different ways. I've only included one example of each topic in this paper, otherwise it would be ridiculously long. If you want to practice any of the topics in more detail afterwards, I'd recommend checking out the other videos on my channel. And if you've done all of these, the next best way to revise is doing past papers. If you head over to my website, firstclassmaths.com, you'll be able to find all of the past papers on there for you. Now that we've got all of that out the way, it's time to go through the answers to the questions. Whilst watching, remember that these are video solutions. I'm going to explain what I'm doing as I'm going along, but in some cases, if you've never seen the topic before, it may seem a bit too fast. If that's the case, then definitely check out the other videos on my channel to learn those topics in more detail. In this first question, we've been asked to expand and simplify. So we're going to start with the expanding part, and let's start with the first bracket here. To expand this, we need to multiply 7 by x, which is 7x, and then 7 by -3, which is -21. Now we move on to the second bracket. So here we've got -2 lots of x minus 10, so we do -2 times x, which is -2x, and then -2 times -10, which is +20. So that's the expanding part of the question done. Now we need to simplify. You can see we have two terms in x here, 7x and -2x. 7x take 2x is 5x. And then we have a -21 and +20. -21 plus 20 is -1. So the answer to this first question is 5x minus 1. For the second part of the question, we need to factorise. To do this, we're going to put brackets back in. So if we take the question, but first of all look at the coefficients. We're looking for a number that goes into 8 and 10. The largest number that we could pick here is 2, so we're going to factorise out a 2. Then we look for each of the letters. Here we have x squared and x, and we want to take out as many of those as possible, but since there's only one x in the second term, we're just going to take out x. And then we've got y and y cubed. Once again, we want to factorise out as many of these y's as possible, but since there's only one in the first one, we can only take out one y. Then we write our brackets, and we need to work out what goes inside. To work out what goes inside the brackets, we need to think about what we would multiply 2xy by to get 8x squared y, and then also minus 10xy cubed. So let's start with the first term. We want to get to an 8, but we've already factorised out a 2, so we must need to multiply by 4. Then we're looking to get x squared, but we've already got one of the x's, so we need one more. And then we're looking to get y, but we've already factorised out the y, so we don't need anything else. So 2xy times 4x will give you 8x squared y. Now we'll move on to the second term. We need a negative, and to get from 2 to 10 you need to multiply by 5. Then we're looking to get x, but we've already factorised out an x, so if we move on to the y's, we need y to the power 3, and we've already got one y there, so we need y squared. So this is the answer to the question. In this question, we need to write 92 as a product of its prime factors. To do this, we take the number in the question, 92, and we think of two numbers that multiply to make it. I'm going to go for 46 times 2. If any of these numbers are prime numbers, we circle those. 2 is a prime number, so we can circle that one, but 46 is not. This means we can split 46 once again. I'm going to go for 23 times 2. Now this time they're both prime numbers, 2 is prime, but also 23 is prime, so we circle both of those. Now we just take all of the numbers in the circles and multiply them together, so we've got 2 times 2 times 23. Since we've got 2 times 2 here, we can write that in an index form as 2 squared. So the answer to this question would be 2 squared times 23. In this question, we have Chloe who buys a phone for £120. She then sells it for £138, and we need to work out the percentage profit. To do this, we work out the profit first of all. You can work out the profit by doing 138 take away 120, which gives you 18. So Chloe has made £18 in profit. But the question wants us to find the percentage profit. To do this, we can use the following formula. We do the change, divide by the original, multiplied by 100. So the change is referring to the profit in the question, that was £18, divide by the original price, that's £120, and then multiply by 100. You can type this into a calculator and you'll get the answer 15. So the answer to the question is Chloe made 15% profit. For the first part of this question, we're going to convert the mixed numbers into improper fractions. To do this, we multiply the 4 by the 2, and then add the 1. 4 times 2 is 8, plus 1 is 9. So this could be written as 9 over 2. We keep the denominator the same. Now we can do the same with the second fraction. So this time it's 1 times 4, then plus 3. 1 times 4 is 4, plus 3 is 7. So this fraction is the same as 7 over 4. So the question could be rewritten as 9 over 2 divided by 7 over 4. When you divide fractions, you can just multiply by the reciprocal of the second fraction. So if we keep the 9 over 2 the same, change the divide to a multiply, but take the reciprocal of the second fraction, as a bit like flipping it upside down. So 4 over 7 instead of 7 over 4. Now we can just multiply these. We do 9 times 4, that's 36, and 2 times 7, that's 14. You could simplify this fraction by dividing them both by 2. 36 divided by 2 is 18, and 14 divided by 2 is 7. Finally, we need to convert this to a mixed number like it asks us to do in the question. So we need to work out how many 7s go into 18, that's 2, and then how many would be left over. Well, 2 7s are 14, so there must be 4 left over to get to 18. So it's 4, and we keep the denominator the same still at 7. So the answer to this one is 2 4/7. For part B of this question, we're also going to convert them into improper fractions first. So we do 3 times 3 plus 2, which is 11, so this is the same as 11 over 3. And for the second one, 1 times 5 plus 2, which is 7, so that's the same as 7 over 5. So the question could be rewritten as 11 over 3 subtract 7 over 5. Now to subtract fractions, you need a common denominator. So we're going to look for a common denominator for 3 and 5. The lowest common multiple of those is 15. So we're going to rewrite both of these as something over 15. Now we need to work out the numerators. For the first fraction, the 3 has turned into a 15, so we've multiplied it by 5. So we need to also multiply the 11 on the top by 5. 11 times 5 is 55. For the second fraction, the 5 on the bottom has become a 15, so we've multiplied by 3. So on the top, we need to multiply by 3 as well. 7 times 3 is 21. Now we can subtract these fractions. We do 55 take away 21, which is 34, and it's over 15 still. Once again, we need to give this as a mixed number, so how many 15s go into 34? Well, that's 2, and there are 4 remainder, so 4 over 15. In this question, we've been asked to make B the subject of the formula. If we look at the formula in its current state, R is the subject, because we can see that R is on its own on the left-hand side. If we look at the right-hand side, there are 2 other things with the B. We've got the 9, and we've got the minus P. So what we're going to do is first of all add P to both sides. If we add P to the right-hand side, that will cancel the negative P that's there, so we'll just be left with 9B. On the left-hand side, if we add P, we have R, and then we add P to that, that's just R plus P. Now on the right-hand side, we have 9B. This means 9 multiplied by B. So we're going to divide by 9 on both sides. If we divide by 9 on the right-hand side, the 9s will cancel, and we're just left with B. And on the left-hand side, we've got R plus P, but we're going to divide that by 9. We would just write that as R plus P, divide by 9. We can now see that B is the subject because it's on its own. But we would normally write the subject on the left-hand side though, so if we just flip this round, we end up with B equals R plus P divided by 9. For the first part of this question, we need to solve this inequality. To solve an inequality, you do exactly as you would for solving an equation, but instead of writing an equal symbol, you write the inequality symbol. So let's begin by adding 2x to both sides of this. If we add 2x on the left-hand side, we have 3x plus 2x, which is 5x, and then we also have this plus 10. If we add 2x to the right hand side, that will cancel the negative 2x that's already there, so we're just left with 5. So we write less than or equal to 5. Now we can subtract 10 from both sides. If we do this on the left, the 10s will cancel, so we have 5x, and on the right, 5 take away 10 is negative 5. Finally, we can divide both sides by 5. 5x divided by 5 is just 1x, and then negative 5 divided by 5 is negative 1. So the solution to this one is x is less than or equal to negative 1. For the second part of the question, we'll need to represent the inequality we just found on the number line shown. So that's this inequality here. To do this, we're first of all going to draw a circle at the number given in the inequality, so negative 1. Then we need to decide which side the arrow is going to go. The numbers we're interested in are less than or equal to negative 1, so we draw an arrow going off to the left. Make sure it goes all the way to the end of the number line. Finally, we need to decide if we're going to shade in the circle or not. If the symbol in the inequality is a less than or equal to or a greater than or equal to, you need to shade in the circle. Since our 1 is less than or equal to, we would shade in the circle. If, however, the inequality symbol was a regular less than without the equal to part, or a regular greater than without the equal to part, you would leave the circle open. For the final part of this question, we need to write down all of the possible values of p for this inequality here. Think of this inequality as having 3 sections to it. We've got the left-hand side, that's negative 9, we've got the right-hand side, that's negative 3, and then in the middle we've got 2p minus 5. Now whatever we do here, we're going to do it to all 3 of those sections. We're going to start by adding 5. So if we write the inequality symbols as they are, on the left we've got negative 9 add 5, that's negative 4. In the middle, if we add 5, the negative 5 will cancel, so it's just 2p, and on the right, negative 3 add 5 is 2. Now we can divide by 2 on all 3 of those sections. So if we write the inequality symbols once again, and on the left, negative 4 divided by 2 is negative 2, 2p divided by 2 is just 1p, and then 2 divided by 2 is 1. So we end up with this inequality here, which is that p is in between negative 2 and 1. But we've been told in the question that p is an integer, which is a whole number. So all of the whole numbers between negative 2 and 1 are negative 2, negative 1, 0, and 1. However, this inequality symbol here doesn't say less than or equal to, it just says less than. This means that p can't actually be equal to 1, so we need to remove 1 from the list. So the final answer to this question is negative 2, negative 1, and 0. For the first part of this question, we need to find the reciprocal of 1.25. To find the reciprocal of any number, you can just do 1 over that number. So we need to do 1 over 1.25. This is just the same as 1 divided by 1.25, which you can type into your calculator. It will give you the answer 0.8. For the second part of the question, we need to write down an error interval. To do this, I like to draw out a number line. I always place the number from the question, so 6.4, in the centre of that number line. Now we've been told that n has been rounded to 1 decimal place. This means we need to find the number that's 1 decimal place below and above 6.4. 1 decimal place below is 6.3, and 1 decimal place above is 6.5. Now we can find the error interval by looking at this region here, the bounds of which are halfway in between 6.3 and 6.4, and also halfway in between 6.4 and 6.5. So, halfway between 6.3 and 6.4, that's this one here, 6.35, and halfway in between 6.4 and 6.5 is 6.45. We can now use those two numbers to complete the answer to the question. It's 6.35 and 6.45. For the first part of this question, we need to write down the modal class. The modal class is the one with the highest frequency. You can see from the table the highest frequency is 28. So the class that corresponds to 28 is 10 to 20. For the next part of the question, we need to write down the interval that contains the median. We're told in the question there are 60 students. So if you do 60 plus 1, which is 61, and then divide this by 2, so 61 divided by 2, you get 30.5. This tells you the person that's in the middle is the 30.5th person. Now obviously you can't have half a person, but for the purposes of this question it won't matter. So we need to look down the table and count up all the frequencies until we go past 30.5. So in the first group we've got 28, then if we include the next group, that's another 13 people, that takes us to 41. You can see we must have now gone past the 30.5th person, so the interval is the second one, 20 to 30. For the final part of the question, we need to write down an estimate for the mean time spent revising. To do this, we're going to do another copy of the table. First of all, we write down all of the midpoints of all of the groups. So the first group from 10 to 20, the midpoint there is 15. The next group, 20 to 30, is 25, and then 35 and 45. You can now multiply all of these midpoints by the frequencies. So 15 times 28, that's 420. 25 times 13, that's 325. Then we get 455 and 270. If we now add up this final column here, we end up with 1,470. This represents an estimate for the total time spent revising for all of the students, but we want the mean time spent revising, so we need to divide it by how many students there are, which is the sum of this column, which is 60. So if we do 1,470 divided by 60, we get the answer to the mean, which is 24.5. In this question, we need to type this into our calculator. We're going to start by pressing the fraction button, then it's 1.8, and then we need to do cubed. You can find that near the top of this calculator. And then we need to get to the bottom of the fraction, so I'm going to press the down arrow here. And now on the bottom I need square root, which is this button over here, and then 17. And then I need to go outside of the square root, so I press the right arrow, and then subtract 2. Then we just press equals, and we end up with this number here, and the question does say to write down the whole calculator display, so we're going to write down the whole display, which is this number here. For the second part of the question, we need to round the answer to the previous part to 3 significant figures. So if we take the number here, the 2 at the front of the number is the first significant figure. This is the second, and this is the third. So this is how far we need to go when we round this number. So if we draw a line after that 4, we need to check this 6 to tell us if we round up or down, and since 6 is above 5, we're going to round this one up. So the 4 is going to round up to a 5. So the answer would be 2.75. In this question, we need to use a ruler and compasses to construct the line BP that bisects the angle ABC. This is asking us to do an angle bisector. To do an angle bisector, you're going to need a pair of compasses. You take the pair of compasses and you place the sharp point right at the point of the angle on B, like this. You then draw yourself an arc that goes across both of the lines of the angle, so like this. This arc will cross the lines in 2 places, here and here. We're now going to draw one arc at each of these crosses, making sure to keep the pair of compasses the same size when we switch. So first of all, place the pair of compasses at this cross and draw yourself an arc like this. And then making sure they stay the same size, place them here on this cross and draw an arc like this. Where these 2 arcs intersect will be the point P. You can now connect up B to P to form the line BP, which is the completed angle bisector. In this question, we've been asked to draw the graph of y equals 3x plus 2. To do this, we're going to draw a table of values. So we have x and y. Now the x values are actually given to us. We're told in the question it needs to go from -2 to 3. So let's put those into the table. -2, -1, 0, 1, 2, 3. Now we need to work out the y values, but we're going to use this formula here. To get any of the y values, we're going to do 3 lots of the x value plus 2. Now I like to start with x equals 0 because that's an easy one. So when x equals 0, y will be 3 lots of 0 plus 2, which is just 2. So when x equals 0, y equals 2. We can add a 2 into the table. Now let's move on to when x is 1. We do 3 lots of 1 plus 2, which is 5. Then when x equals 2, we do 3 lots of 2 plus 2, which is 8. And then for x equals 3, 3 lots of 3 plus 2, which is 11. Then we move on to the negative ones. We need to do 3 lots of -1 plus 2, which is -1. And finally, 3 lots of -2 plus 2 is -4. Now some people have some difficulty with the negative ones here, and since this is a straight line graph, you may notice that we're just subtracting 3 each time. So once you've done the positive numbers here, you could just do 2 take away 3, which gives you -1, and then -1 take away 3 is -4. Now we need to plot each of the coordinates. So the first one is at -2, -4. That goes here. The next one is at -1, -1. That goes here. Then we have 0, 2. That goes here. Then 1, 5. That's here. 2, 8. And 3, 11. Once you've plotted all of those, you can join them up with a nice straight line. It will look something like this. For the second part of the question, we have to decide if the point with coordinates 25, 77 lies on the line. So if we take the coordinates 25, 77, the 25 is the x coordinate, and the 77 is the y coordinate. So we just need to check that if we substitute in these numbers, we end up with something that makes sense. So let's replace x with 25 and see if we get 77. So remember it's 3x plus 2, so 3 lots of 25 plus 2, 3 25, so 75, plus 2, which is 77, which is the y coordinate. Since this works, the point is on the line, so we could say yes. In this question, we need to work out an estimate for this calculation. This means we don't need to do it exactly, we just need to know roughly, and we can do this by rounding each of the numbers to one significant figure. Let's start with the 699. To one significant figure, that's 700. Then we move on to 32, to one significant figure, that's 30. And finally, the 0.21 on the bottom would round to 0.2. So we just need to work this out. To work this out, we can start with the top. 700 times 30, well, we can do 7 times 3, that's 21, and then we need 3 more zeros. And on the bottom, we just have 0.2. Some people find this a little bit tricky. To divide by 0.2, you're better off multiplying both the top and bottom of this by 10. If we multiply the top by 10, we get 210,000. And if we multiply the bottom by 10, 0.2 times 10 is just 2. This calculation gives the same answer. So we can do 210,000 divided by 2, which is 105,000, and the answer to the question. In this question, we're told the circumference of the circle is 20% greater than the perimeter of the triangle. We're also told that the triangle is an equilateral triangle, which means all of the sides are the same length. So we know that this is 8 and this is 8 as well. So the perimeter of the triangle is not too hard to find, we just add up all of those sides. 8 plus 8 plus 8 is 24. Now if we've been told the circumference is 20% greater than this, we just need to increase that number by 20%. So if you do 100% plus 20%, you get 120%, and then take 120 and divide it by 100, you get 1.2. This is a multiplier for increasing by 20%. So we can multiply the 24 by 1.2, which gives us 28.8. So this is the circumference of the circle. But we've been asked to find the area of the circle. To find the area of a circle, you need to know its radius. So the formula for the circumference of a circle is pi times diameter. Now that we know the circumference, we can use this formula to work out the diameter. If the circumference is equal to pi times the diameter, we can divide the circumference by pi to get the diameter. So if we take the circumference, which we know is 28.8, and divide it by pi, we get this number here, which must be the diameter of the circle. The diameter is always twice the radius, so if we divide this by 2, we end up with the radius, which is this number here. Now that we have the radius, we can work out the area using the area of a circle formula. To work out the area of a circle, you use area equals pi times r squared. So we just need to do pi times the radius squared that we found, 4.58, and so on. And if you type this into your calculator, you get this number here. The question says to round it to 3 significant figures, so if we round it, we'll end up with 66.0. For this question, we need to find the number of triangular tiles in pattern n. This just means we need to find an nth term of a sequence, where the sequence is just the number of triangles in each of the patterns. So let's write down that sequence. For pattern number 1, there are 6 triangles. In the second pattern, there are 8. And the third pattern, if you count them all, you get 10. We just need to find the nth term of this sequence. To get from 6 to 8, you add 2. And also, to get from 8 to 10, you add 2. So it's a linear sequence of the form 2n, since it goes up by 2 each time. But 2n just describes the 2 times table. So if we just write the 2 times table above the sequence, 2, 4, 6, and so on, we need to work out how to get from the blue numbers to the red numbers. Now in all cases, to get from 2 to 6, 4 to 8, 6 to 10, and so on, you're going to add 4. This means the nth term of this sequence is 2n, which is the blue sequence, plus 4, which gives you the red sequence. In the second part of the question, we're told that Rich is going to make one of the patterns from the sequence, but he's going to use 88 total tiles. This means those tiles could be square or triangular. We need to work out how many square tiles Rich used. So let's now write out a sequence which isn't the number of triangular tiles, but the number of total tiles. In pattern number 1, you've got 6 triangles and 2 squares, so that's 8 tiles. In pattern number 2, you have 4 squares, 8 triangles, that's 12 tiles total. And if you count up all of those tiles in pattern number 3, it's 16. This is once again a linear sequence. This goes up by 4 each time, so it must be a 4n sequence. if we write the 4 times table above the sequence, 4, 8, 12, and so on, we can see that to get from the blue sequence to the red sequence, you must add 4 again. So this one is 4n plus 4. Now we know that Rich is going to use 88 total tiles. So if we say 4n plus 4 equals 88, we can find out which pattern number he's making. This is just an equation to solve. If you subtract 4 from both sides, you get 4n equals 84, and then divide both sides by 4, you find that n is equal to 21. This means Rich is making pattern number 21. But the question said how many square tiles is he using? Well, if you count up the number of square tiles in each pattern and compare it to the pattern number, you'll see it's just double. The first pattern, pattern number 1, has 2, pattern number 2 has 4, pattern number 3 has 6, and so on. So if we've got pattern number 21, we just need to double 21. 21 times 2 is 42. In this question, we're told the number of people visiting a cinema on Saturday was 20% more than it was on Friday. So from Friday, if we add 20%, we get the number for Saturday. Then we're told the number of people who visited on a Saturday, that's 9,840, so let's write that underneath Saturday. And we need to work out the number that visited on Friday. So let's call that number x, since we don't know what it is yet. So if we take x, then add 20%, we need to get to 9,840. To increase a number by 20%, you multiply it by its multiplier, 1.2. So we end up with x times by 1.2 equals 9,840. To solve this, you can divide both sides by 1.2. On the left, this will give you x, and on the right, 9,840 divided by 1.2. You can use your calculator for this, and it will give you the answer 8,200, which is the answer to the question. For the first part of this question, we need to simplify a fraction. Let's start with the numbers. So we can do 15 divided by 3 quite easily, that's 5. Then if we move on to the letters, we got x to the 6 divided by x. When you divide like this, you're going to subtract the powers. The power of x on the bottom is 1, so we do 6, take away 1, which is 5. So x to the 6 divided by x is x to the power 5. Then if we look at the y's, we've got y to the 8 divided by y to the 2. Again, we'll subtract the powers, 8 take away 2 is 6. So it's y to the power 6. For the second part of the question, we have 2y cubed, all in a bracket to the power 5. If you raise something to the power 5, you times it by itself 5 times. So we've got what's inside the bracket, 2y cubed, times by itself 5 times. So 2y cubed times 2y cubed times 2y cubed, and again, and again. You can see we've got that 5 times. So we just need to times all of these together. We'll start by multiplying all of the 2's. 2 times 2 times 2 times 2 times 2 is 32. Then we look at the y's. We've got y to the 3 times by itself 5 times. Here we can just add up all of those 3's. 3 add 3 add 3 add 3 add 3, or 3 times 5, which is 15. So it's y to the power 15. For the first part of this question, we need to expand and simplify a double bracket. To do this, we multiply everything in the first bracket by everything in the second bracket. So let's start with x times x, which is x squared. Then x times negative 8, which is negative 8x. Then negative 5 times x, which is negative 5x. And finally, negative 5 times negative 8 is a positive 40. We can then simplify these middle two x terms here. Negative 8x subtract 5x is negative 13x, so we end up with the answer x squared subtract 13x plus 40. In the second part of the question, we've been asked to factorise. This means we need to put it back into its bracketed form. This is a particular type of factorisation called the difference of two squares, because 4x squared is a square and 9 is a square, and it's the difference because we've got a subtraction. You should notice that 2x times 2x is 4x squared, and 3 times 3 is 9. This means our brackets must be made up of a 2x and a 3, and when it's a difference of two squares, one of them is positive and one of them is negative. So we end up with 2x plus 3 and 2x minus 3. For the final part of this question, we need to solve a quadratic equation. This one we can do by factorising. We're going to look at the final term here, negative 8. We need to think of two numbers that would multiply to give negative 8. You could have 1 times negative 8, or 2 times negative 4, but you could also flip the signs around here and have 8 times negative 1 and 4 times negative 2. All of those pairs of numbers will multiply to give negative 8. But only one of those is going to add to give 2. We need to get 2x here. So if we add all of these together, the first one, 1 add negative 8 is negative 7, 2 add negative 4 is negative 2, 8 add negative 1 is 7, and 4 add negative 2 is 2. So the one we're interested in is the bottom one here. You can see it was 4 and negative 2, which means the brackets will be x plus 4, x subtract 2. Now the question didn't say factorise, otherwise we'd be finished. It said solve, and you can see it says equals 0 over here. So this one also equals 0. Now what we have here is two brackets multiplied together to give 0. If you're going to multiply two things together to get 0, then at least one of them must be 0. So either the first bracket 0, or the second bracket 0. This just gives us two equations to solve. For the first one, you subtract 4 from both sides, and you'll get x equals negative 4, and the second one, you add 2 to both sides, and you get x equals 2. In this question, we've been told that we have a floor that has an area of 10 square meters, and it's going to be tiled by 3 workers in 8 hours. But we need to tile a bigger floor. It's going to be 25 meters squared, and we're also going to have more workers, so 4 workers. For the moment, let's stick with the 10 square metered floor. We've been told that if it's 10 square meters, we can tile it with 3 workers in 8 hours. If you multiply 3 times 8, this tells you it takes 24 worker hours to tile that floor. Now let's think about how long it would take to tile the same floor of the same size with an extra worker, so with 4 workers. How many hours would that take? Well, we know it takes 24 worker hours to complete the tiling of the floor, but we have 4 workers, so they're going to share out that time equally. So if we do 24 divided by 4, we end up with 6. So it would take 6 hours for 4 workers to do the same size floor. And it makes sense that it would take 6 hours, since you have more workers, it would take less time. But the question didn't want us to do an area of 10 square meters still. It's a bigger area of 25 square meters. But how many times bigger is that? Well, if you do 25 divided by 10, you find out this floor is 2.5 times bigger. If the floor is 2.5 times bigger, it will take 2.5 times as long. So we found out earlier it was going to take 4 workers 6 hours to do the smaller floor, so we just need to multiply this 6 by 2.5 to see how long it would take to do the larger floor. 6 times 2.5 is 15, which is the answer to the question. 15 hours. In this question, we have a lorry that takes a direct 60-mile route from A to B, travelling at an average speed of 50 miles per hour. So it's going along this route here, and its speed is 50 miles per hour. We've then got a car that's going from A to B as well, but it's going through point C along the route. So the car will start at A, go to C, and then go from C to B. We're also given information about the speed of the car between A and C, so the blue part of the route. For that part, it's going at 60 miles an hour as its average speed. Then we're told that both vehicles depart A at the same time and arrive at B at the same time. And we need to work out the average speed of the car between C and B. Now if you look at the red section and the blue section of this diagram, you can see we have both of the distances and both of the speeds. So we can use the formula time equals distance divided by speed to work out the time for each of those sections. Let's do the red one first. So the distance for the red one is 60 miles, and we're going to divide it by its average speed, which is 50 miles per hour. 60 divided by 50 is 1.2 hours. Then we'll do the same from A to C, the blue section. So this time the distance is 45, and the speed is 60. 45 divided by 60 is 0.75 hours. Now since we know the car and the lorry take the same amount of total time to complete their journeys, we can subtract these two to find out how long the purple section is from C to B. So if we do 1.2 hours, take away 0.75 hours, we get 0.45 hours. That means the car must take 0.45 hours to go from C to B. Now that we know the time it takes and we know its distance, we can work out the speed. We use the formula speed equals distance divided by time. The distance in this one is 18, and the time, we just worked that out, is 0.45 hours. 18 divided by 0.45 is 40 miles per hour. And that's the answer to the question. In the first part of this question, we're looking for the point that's the outlier. The outlier is the point that doesn't fit with the trend for the rest of the points. So that's this one here. The coordinates of this outlier are 32 and 620. For all of the other points, we need to write down the type of correlation. Since this data has an upward trend, we'd say it has a positive correlation. For the final part of the question, we have a person who is aged 55, and we need to use the graph to estimate their reaction time. To do this, you need to draw a line of best fit. A line of best fit is a line that goes through the general trend of the points we've been given. So it would look something like this. Now everyone will draw a slightly different line of best fit, but there are a few key features to look out for. Lots of people tend to start their line of best fit right in the bottom left corner, but in fact in most cases it probably won't do. Secondly, a good rule of thumb is to try and get the same amount of crosses above and below the line. You can see on mine they're roughly equally spread above and below the line. Finally, you need to make sure it's following the general trend of the points. Remember we said this was a positive correlation, you can see the points go in an upward trend, so our line must go upwards too. Now we can use this line to find out the reaction time of that person who was aged 55. So if we go to 55 on the bottom axis where it's the age, and go up to the line of best fit, and then read off the corresponding reaction time, you can see that comes in at around 560 milliseconds. Now you may get a slightly different answer depending on your line of best fit. For the first part of this question, we need to describe the single transformation that maps triangle A onto triangle B. Now there are 4 different types of transformation you need to know. They are reflection, rotation, translation, and enlargement. Now we can see that shape A to shape B here has just been moved, and we call that a translation. So you would write down translation to get the first mark. When describing a translation, you need to give a vector to describe how it's been moved. So if we take the shape A, and see how do we move it to get to shape B? Well, we go 1 square to the right, 2 squares to the right, and 3 squares to the right. So we could say it's a translation by the vector, and then we draw a vector, and since it went 3 to the right, we put a 3 at the top, and since it didn't go up or down at all, we put a 0 at the bottom. For the second part of this question, we need to do a rotation. It's going to be 90 degrees anti-clockwise about the point 1, 0. First of all, take a piece of tracing paper and trace the shape. Then you're going to mark a cross at the point given, so 1, 0, that's here. Then place your pen on that cross and turn the tracing paper 90 degrees anti-clockwise. That's 1/4 of a turn to the left, so like this. You can then draw the shape in this place and remove the tracing paper. It says to label it triangle C, so we'll do that as well. For the final part of this question, we've been asked to do a reflection of triangle A in the line y equals 2. The line y equals 2 is a horizontal line that cuts the y-axis at the point 2, so this one here. We can now reflect triangle A in that line. It will just flip down below that line since it's touching the line and look something like this. And the question asks us to label this triangle D. In this question, we've been asked to work out the perimeter of the kite. To do its perimeter, we need to know the length of all of its sides. You can see we know 2 of them, but we don't know the other 2. So let's start by trying to work out the length of this one here from D to C. If we just look at this triangle here, we can see we have a right angle in it, so it's a right angled triangle. This means we can use Pythagoras to find the missing length. Also notice in the question though, it says to give our answer in centimetres. We've got one of the sides at 78 centimetres, but the other one's in metres. So let's convert the 1.3 metres into 130 centimetres. Now we're ready to use Pythagoras. So if we square both of those sides, 130 squared is this, and 78 squared is this. Obviously use your calculator for those. Then we need to decide if we're going to add or subtract those sides. Since this side here, the one we're finding, is not the hypotenuse, we're going to subtract them. So if we subtract those numbers, we end up with this. Now to find the answer for the length of DC, we need to square root that, and we end up with the answer 104. So from D to C is 104, but since it's a kite, that's also the distance from B to C. Now we know all of the sides of the kite, we can just add those together. We've got 78 add 78, add 104 add 104. And this gives you the answer 364 centimetres. In this question, we're told that Craig spends 30 minutes longer revising chemistry than he spends revising physics. If we look at the pie chart, you can see the angle for biology is 90 degrees, that's a right angle. So we can work out the angle for physics as well, since all 3 of the angles need to add up to 360. So if we do 90 plus 160, we get 250, and if we subtract that from 360, we get 110. So the angle for physics must be 110. Now if Craig is going to spend 30 more minutes on chemistry than he is on physics, that 30 minutes must be represented by the difference in their angles. If you subtract the angles, 160 take 110, you get 50 degrees. This means in our pie chart, 50 degrees represents 30 minutes. But we need to work out how long Craig is going to spend revising biology, and in the pie chart that's 90 degrees. So we need to work out how we can get from 50 degrees to 90 degrees. I'm going to work out how we get to 10 degrees first. To get from 50 degrees to 10 degrees, I would divide by 5. So if I divide 30 minutes by 5, I get 6 minutes. This means every 10 degrees of the pie chart represents 6 minutes. Now, how can I get from 10 degrees to 90 degrees? Well, that's just times by 9. So 6 times 9 is 54 minutes. So the answer to this question is 54 minutes. In this question, we need to work out the vector 2a subtract b, using the vectors a and b we've been given. So we need two lots of the vector a, which is negative 6, 5, and we're going to subtract the vector b, which is 2, negative 2. To work this out, we're first of all going to work out what two lots of vector a is. To multiply a vector by 2, you just double the numbers in the vector. So instead of negative 6, we've got negative 12, and instead of 5, we've got 10. So it's negative 12, 10, subtract vector b, which is 2, negative 2. Now we just have two calculations to do. Along the top, we've got negative 12, subtract 2. If you do negative 12, subtract 2, you get negative 14. On the bottom, we've got 10, subtract negative 2. When you subtract a negative number, that's just the same as adding the positive version. So it's the same as 10 add 2, which is 12. So the answer to this question is negative 14, 12. For part B of the question, we need to draw and label the vector negative a. The vector negative a is the same as vector a, apart from we switch the signs. So instead of being negative 6, 5, it's 6, negative 5. Now when we draw the picture of this, we need to consider what direction that vector is telling us to go. The top number tells you to move left or right, and since it's positive, it's right, so it's 6 to the right. The bottom number is for up and down, and since it's negative, we're going to go down, so 5 down. So we just pick a point on this grid, and then go 6 right, and then 5 down, and this is the final point. We can draw a line that connects these two together, and we put an arrow on that line to indicate the direction the vector goes. For the final part of the question, we need to draw another vector, but it needs to be perpendicular to vector b. Vector b is this one here. That means to move 2 right and 2 down. So if we were to draw vector b, it would look like this: 2 to the right, 2 down, and an arrow to indicate the direction. But we don't need to draw vector b, we need to draw one that's perpendicular to it. A vector that's perpendicular to this will cross it at 90 degrees. So we need to draw any vector that goes in this direction instead. It doesn't actually matter how long that vector is, as long as it goes in this direction. It could be this long, it doesn't matter. In this question, we've been asked to work out the maximum number of pancakes that can be made with these ingredients. We've been told the recipe for 12 pancakes in the question. If we look at the first ingredient, flour, for 12 pancakes you'll need 300 grams of flour, but we have more flour than this available. We have 1,500 grams, so we can definitely make more than 12 pancakes, but the question is how many? Well, if we do 1,500 divided by 300, we end up with 5. This means we could repeat the recipe for 12 pancakes 5 times with all that flour that we have. How would this work for milk? Well, for 12 pancakes we need 400 millilitres, but again we have more, 1,800 millilitres. So if we do 1,800 divided by 400, we end up with 4.5. So we can repeat this recipe for 12 pancakes 4.5 times. If we do the same for eggs, we need 2 eggs, we've got 11 eggs. If you do 11 divided by 2, you get 5.5. This means we have enough eggs to repeat this recipe 5.5 times. Now the most important of these three numbers is the smallest one, 4.5. Since even though we have enough flour to repeat this recipe 5 times and eggs to do it 5.5 times, that doesn't matter because we would have run out of milk. So the lowest one is the most important one, and that's the one we're going to need to use. So if we remember, we're trying to work out the maximum number of pancakes, and we know we can repeat this recipe for 12 pancakes 4.5 times. So if we do 12 times 4.5, we end up with 54, which is the maximum number of pancakes. In this question, we've been asked to write some numbers in order of size, and we need to start with the smallest one. To compare these numbers, we're going to convert them all to decimals. So let's start with the first one here, 8.6 times 10 to the power 4. Timesing a number by 10 to the power 4 is timesing it by 10 4 times. So let's take 8.6 and times it by 10 once, and a second time, a third time, and a fourth time. So this number is 86,000. The next one here, 0.086, is already a decimal. And if we move on to the next one, we have 86 times 10 squared. That's timesing by 10 twice. So if we times by 10 once, and twice, we end up with 8,600. And for the final number, it's 8,600 times 10 to the power negative 4. This is like dividing by 10 4 times. So if we start with 8,600 and divide by 10, a second time, a third time, and a fourth time, we find this is equal to 0.86. Now it's quite easy to see which one's the smallest. That's 0.086, so let's put that onto the answer line. The next one is 0.86, but remember in the question that was 8,600 times 10 to the power negative 4. The next one is 8,600, and that's 86 times 10 squared. And the final one, 86,000, which is 8.6 times 10 to the power 4. For this question, we need to draw a frequency polygon. Whenever we do a frequency polygon, we need the midpoints of all of the groups. So for the first group from 60 to 70, the midpoint is 65. The next group from 70 to 80, that's 75. Then we get 85, 95, and 105. Now what we need to do is plot at each of these midpoints the associated frequency. So the first midpoint is 65 and the frequency is 3. So we go across to 65 on the bottom and go up to 3. We do the same with 75 and 12, which goes here. And 85 and 15, that goes here. 95 and 44, that's all the way up here. 105 and 26, that goes here. You then connect up each of these points in order from left to right, like this, with straight lines. And there's your completed frequency polygon. In this question, we've been given the universal set of numbers from 1 to 10. This means the only numbers we need to place inside this diagram are the numbers from 1 to 10. We've been told that set A is the multiples of 3, so this is the 3 times table. But again, we're only interested in the numbers that are from 1 to 10. So the multiples of 3 that are from 1 to 10 are 3, 6, and 9. Then we have set B, which says the factors of 12. So we want to know any factors of 12 that are also from the numbers 1 to 10. So that's 1, 2, 3, 4, and 6. Notice we don't put the number 12. Now we're going to go through each of these numbers and see which sets they're in to help us place them in the Venn diagram. Let's start with the number 1. The number 1 is not in the set A, it's not a multiple of 3, but it is in the set B, the factors of 12, so it goes inside the B circle only. This is exactly the same for the number 2, but then the number 3 is in set A and set B, so it goes in the overlap in the middle here. Then we move on to 4, that's only in set B again, and then we hit 5. Now 5 is not in set A or set B, so it goes outside of the circles but still inside the rectangle. Then 6, that's in both of them, so into the middle again. Then 7, that's not in A or B, so that goes in the outside. Then on to 8, that's the same as 7, so in the outside again. 9 is in set A, but not in set B, so that's just inside the A circle. And then 10, which goes in the outside. For the second part of the question, we've been told we're going to select a number at random from the universal set, and we need to find the probability it's in A, then this symbol, B. This symbol is the union symbol. Sometimes we read this as A or B. If we're to show the union in a diagram, it's both of the circles A and B combined. So we need to count up how many numbers are in the union. So there's 1, 2, 3, 4, 5, 6. So there are 6 possible numbers that we could pick that are in the union, and 10 possible numbers altogether. So the probability of picking one that's in the union is 6 over 10. In this question, we've been asked to multiply two numbers that have been given in standard form. To do this, we're going to multiply the number parts of them first, so 8 times 3, that's 24, and then we multiply the powers of 10. 10 to the power 10 times 10 to the power 3 is 10 to the power 13. The reason for this is you add the powers. 10 add 3 is 13. Now the question does say to give your answer in standard form, and this is not at the moment. The number at the front there, that 24, needs to be between 1 and 10. So we're going to divide that 24 by 10, which will give us 2.4. That is between 1 and 10. But we can't just divide this number by 10, that would change the number. But if we also multiply it by 10, that would put it back. So if we multiply the 10 to the 13 by 10, we get an extra power of 10. So it's now 10 to the power 14. So both these two numbers are the same, but the bottom one is written in standard form. For the second part of the question, we have a fraction to deal with. We're going to just look at the numerator first. 1 times 10 to the 3 is 1000, and 2 times 10 to the 2 is 200. So the top is really saying 1000 plus 200, which is 1200. We can rewrite that in standard form. That would be 1.2 times 10 to the power 3. So the numerator really looks like this, and on the bottom, we have 4.8 times 10 to the power negative 2. Now when you divide numbers in standard form, you look at the number part again, so we've got 1.2 divided by 4.8. Now you should realise that 12 times 4 is 48, so this would actually simplify to give 1/4, or as a decimal, 0.25. Then we look at the powers of 10. 10 to the 3 divide by 10 to the negative 2. When you divide powers of 10, you subtract the powers, So we need to do 3 take away -2. If you subtract a negative, we actually need to add, so it's 3 add 2, which is 5. So it's times 10 to the power 5. Once again, unfortunately, this is not in standard form. The first number is not above 1. So we're going to multiply this one by 10 this time, which will give you 2.5. But again, you can't just multiply numbers without consequence. We also need to divide it by 10 to keep everything balanced. If you divide this number by 10, you're reducing the amount of 10s you're multiplying by, so it's now 10 to the power 4. In this question, we're trying to find out which bottle is better value for money, and we've been given this exchange rate, £1 is equal to 1.17 euros. With this exchange rate, we can convert from pounds to euros by multiplying by 1.17. Or alternatively, we can go from euros back to pounds by dividing by 1.17. For this question, there are actually many different routes that can lead you to the right answer still. I prefer to work in pounds, so I'm going to convert the euros from the bottle in Spain into pounds first. So to do this, I go from euros to pounds, which is divided by 1.17. So if we take the 2.4 euros, divide it by 1.17, we find the cost in pounds, which is £2 and a bit more than 5 pence. Now that we've got both of them in pounds, we need to work out which one's better value for money. To work out which one's better value for money, I like to do the price in pence, and then divide this by the amount that we have. So for the first bottle, the one in the United Kingdom, the price in pence would be 299 pence, and I'm going to divide it by how many millilitres we have, and 2 litres is 2,000 millilitres. I use my calculator at this point, and I end up with this number here. Now I'm going to do exactly the same for the one in Spain. So the price in pence, which is a little bit more than 205 pence, divide by the amount that we have, which is 1,250 millilitres. If you do this one in your calculator, making sure to use the number 205 and all of the digits after it, you end up with this. This tells us that if we buy the one in the United Kingdom, it costs us 0.1495 pence for each milliliter of drink. And the one in Spain is 0.1641 pence for each milliliter of drink. So the one that's better value for money is the one that has a lower number here, so that's the one in the United Kingdom. To start this question, we need to draw the front elevation of this shape. That's what you would see if you viewed the shape from the front. You can see they've marked the front onto the question, so we would see this face here. So we just need to draw this face onto our grid. We'll start on the left-hand side. You can see its height is 4 centimeters, so let's draw a 4 centimeter line. Then going along the bottom, we've got a 6 centimeter line horizontally, so let's draw a 6 centimeter line. Then going up the right-hand side, it's much smaller, it's only 1 centimeter. Then we go to the left 2 centimeters, and then we connect this point back up to the start. Now for the side elevation, this is what you would see if you viewed the shape from the side, which is also marked onto the diagram. You would see this face here, which is a rectangle, which is 3 centimeters by 1 centimeter, but you would also see this sloped face here. Now this one's a little more difficult. The number 5 centimeters there may confuse some people. The height of that is not 5 centimeters. The total height of the shape, if you look at the far left-hand side, is 4 centimeters. So if we viewed the shape from this side, the maximum height we would see would still be 4 centimeters. So we just need to draw 3 more centimeters up, and then complete the shape like this. Finally, we're on to the plan. The plan is what you would view if you saw the shape from above, which would be these 2 faces here. Once again, that 5 may cause some problems. If you look at the horizontal width of the shape, right at the bottom, you can see it's 6 centimeters. So that would be the width of the rectangle you would see. Certainly not 5 plus 2, which gives you 7. So we need to draw a rectangle which is 6 wide, and then if you look at the 3 centimeters by the side, that's going to be the height of this rectangle. So it goes up 3, and then we complete the rectangle like this. Now additionally, you would see this line here, which joins those 2 rectangular faces together. That's 2 centimeters in from the right hand side, so if we go in 2 centimeters, we would draw this line here. For part B of this question, we need to work out the volume of the prism. We're going to use the formula, which is the volume of a prism is the area of its cross-section multiplied by its length. The cross-section is the original shape we drew, the front elevation here. So we need to find the area of that shape. It's actually quite easy to do this using the elevation we've drawn. If we split the elevation into 2 shapes, a rectangle and a triangle, for the rectangle we can just count the squares, there are 6 of those, so it's 6 centimeters squared, and for the triangle we can work out the formula by doing the base times height and divide by 2. The base is 4, the height of the triangle is 3, 4 times 3 is 12, and half of that is also 6. So the total area of that cross-section is 6 add 6, which is 12. Now we multiply this area of the cross-section by the length of the prism, which is 3 centimeters, so we do 12 times 3, which is 36. And that's the answer to the question. In this question, we have to solve some simultaneous equations. If we look at the equations in their current form, then none of the corresponding coefficients are matching, so we're going to need to scale the equations. I'm going to try and make the x's match by multiplying the first equation by 4 and the second equation by 5. So for the first equation, we do 5x times 4, which is 20x, 3y times 4, which is 12y, and 5 times 4, which is 20. For the second equation, it's 4x times 5, which is 20x, negative 2y times 5, negative 10y, and negative 7 times 5, negative 35. You can now see the coefficients of the x terms are matching since they're both 20. Since the signs of those are both the same, they're both positive, we subtract the equations. 20x take away 20x is 0. 12y subtract negative 10y is 22y, since you need to do 12 plus 10. When you're subtracting a negative, remember, it's like adding. And then 20 take away negative 35. Once again, we're subtracting a negative here, so we need to do 20 plus 35, which is 55. To get y, you can just divide both sides by 22, so y equals 55 divided by 22. This fraction will simplify nicely, since they're both multiples of 11, it would give you 5 over 2, which is the same as 2.5. So now we found y, we want to try and find x. We need to substitute this y value back into one of the original equations. I'm going to go for this first one here. So I'm going to copy out that equation, but whenever I get to a y, I'm going to write 2.5. So we have 5x plus 3 lots of y, which is 2.5, equals 5. 3 lots of 2.5 is 7.5, so this is just 5x plus 7.5 equals 5. We can solve this by subtracting 7.5 from both sides. On the left, that will give you 5x, and on the right, negative 2.5, and then divide both sides by 5. This gives you x equals negative 0.5. So we have our two solutions, x is negative 0.5, and y is 2.5. In this question, we need to calculate the surface area of the square base pyramid. To find the surface area, we need to work out the area of all of the faces. This shape has 5 faces, there's 1 square, and 4 triangles. Let's start with one of the triangles. The triangle would look something like this. The base is 10, and both of the other two sides are actually 13. We can see that from the information we've been given about the sides. We know that side EC must be the same as side ED. Now to find the area of this triangle, we need its height. If we just look at half of the triangle, this part here, we can use Pythagoras to work out that height. Since we've split the triangle in half, the line along the bottom here must be 5 centimeters, since that's half of 10. If we now do the hypotenuse squared, take away that short side squared, so 13 squared take 5 squared, we end up with 144. If you square root 144, you get 12. So the missing side here, the height of the triangle, must be 12 centimeters. We can now use this to work out the area of the triangle. The area of the triangle would be 1/2 times the base, which is 10, times the perpendicular height, which is 12. If you do this, you'll end up with 60. So each of the triangles is 60 centimeters squared. Now let's look at the square on the base. The side length of that is 10, so the area of the square is simply 10 times 10, which is 100. So now we just need to add up all of these areas. We've got 4 of the triangles, so we'll take 4 lots of 60, and then add to this the square, which is 100. When you do 4 times 60, you get 240, add 100 is 340, which is the answer to the question. In this question, we need to complete a distance time graph. We've been told that Sovra stays at the dentist for 45 minutes. We can see from the part that's already drawn that she arrives there at 10:45 AM. So if we do 10:45 plus 45 minutes, we end up at 11:30. Now if she's staying at the dentist for 45 minutes, her distance from home won't change. So we just need to draw a horizontal line for 45 minutes, like this. For the next section of the graph, we're told that she drives home at a constant speed of 32 miles per hour, so we know the average speed for that journey home. We also know the distance for that journey home, because the distance that she lives from the dentist is the highest value here, 40 miles. So we can use the formula time equals distance divided by speed to work out how long it's going to take, since we know the distance and the speed. The distance was 40 miles, and the speed was 32 miles per hour, so 40 divided by 32 gives you 1.25 hours, which is the same as 1¼ hours. So we know she's going to leave the dentist at 11:30, so we just add 1¼ hours to this, or 1 hour and 15 minutes, and we end up with 12:45 PM. So we can now draw the final section of this graph. If we start where we left off at the dentist at 11:30, we can then return home for 12:45. We're going to draw a straight line because it said she travels at a constant speed. In this question, we need to work out the value of x. We're going to start by finding the total sum of all of the angles inside a pentagon. We can do this using this formula. The interior angle sum is the number of sides subtract 2 multiplied by 180. So the pentagon has 5 sides, so we do 5 take away 2 times 180. That's the same as 3 lots of 180, which is 540. So this tells us the sum of all of the angles inside a pentagon is 540 degrees. But this pentagon is special. It's a regular pentagon, which means that all of the angles on the inside will be the same. So we can do 540 divided by the 5 angles, and we get 108. This means that all of the interior angles of a regular pentagon are 108 degrees, including this one here. Now we've also been told that ABFG is a square. The interior angle of a square is 90 degrees, so this one here is 90 degrees. We can now find the angle x by doing 108 degrees, subtract 90 degrees, which is 18. So the answer to the question, the value of x is 18. For this question, we need to work out how much more money Tia is going to make going with Bank A compared to Bank B. So let's start with Bank A. In Bank A, we've got an interest rate which is 2.5% and it's compound interest. We know that Tia is going to invest £5,000 for 3 years. First of all, we need to work out what the multiplier is for a 2.5% increase. So let's say 100% plus 2.5%, which is 102.5%, and then if we divide that by 100, we get 1.025. So a multiplier for a 2.5% increase is 1.025. So if we take Tia's money, £5,000, and we multiply it by this multiplier, but we need to do that 3 times, 1 for each of the years, so we put a power 3. If you type this into your calculator, you'll get this number here. Now, of course, the answer here is monetary, so we need to give it to 2 decimal places, so it would be £5,384.45. Now let's look at Bank B. For Bank B, we've got 2 different interest rates. The first year is 4%, but all other years are 1%. So we're going to take the same amount of money, £5,000. For the first year, it's going to increase by 4%. That's a multiplier of 1.04, but then all the other years, it's 1%. So that's a multiplier of 1.01. But since there are 3 years in total, we need 2 years at 1% because there's only 1 year at 4%, and that makes 3 years total. So we're going to square the 1.01. If you type all of this into your calculator, you'll get this number here. So you can see that Bank A does give us more, but the question says how much more, so we're just going to subtract them. When you subtract them, you'll end up with this number here, £79.93. In this question, we need to work out the length of AC, so we can label this onto our diagram as x. This is a trigonometry question, so we need to label all of the sides of the triangle. Let's start with the hypotenuse, that's the longest one opposite the right angle here. Then the one that we call the opposite is opposite the angle that's been given, so opposite the 81 is this one here. And finally, the last one is the one that's the adjacent next to the angle, that's this one here. Now if you look at each of the sides, you'll see that 2 of the sides have paired up information. One of them doesn't though. You can see that A is with the 11 and the O is with the X, but the H is alone all by itself. This tells us we're not going to need the hypotenuse for this question. Now we write out the phrase SOHCAHTOA. We need to pick the one of these that contains the A and the O that we've got left in the question. That would be TOA, which means we're going to need to use tan. So we can write out that tan of the angle, which is 81, is equal to the opposite, which is X, over the adjacent, which is 11. This is just an equation to solve. We can multiply both sides by 11. On the left, this will give us 11 times tan 81, but on the right, the 11s will cancel, so we just have X. You can now just type this straight into your calculator and you'll find the value of x, which is this number here. The question asks to give your answer to one decimal place, so if you rounded this, you'd get 69.5. This question is also a trigonometry question, but this time we're trying to find the sides of angle CAB. Let's mark that on as x here. Once again, we're going to label the triangle, the hypotenuse first, the longest one opposite the right angle, then the opposite the angle in the question, and finally the adjacent next to the angle in the question. Once again, we're going to cross out the piece of information that's by itself. This time is O, so we don't need the opposite for this question. If we now look at SOHCAHTOA, you can see we've got A and H left, so we need to use CA. So we can write down that cos of the angle, and the angle is x, so cos of x, equals the adjacent, which is 8, divided by the hypotenuse, which is 13. For a question like this, when you're finding an angle, you need to use the inverse trig functions. So we can now write that x equals inverse cos of 8 over 13. If you type this into your calculator, you'll get this number here. Once again, we need to round to one decimal place, so the final answer is 52.0. In this question, we need to complete the table, so we need to find the probabilities for blue and for green. Two probabilities we have already are red at 0.8 and yellow at 0.1. If we add these together, we get 0.9. You can now subtract this from 1, which gives you 0.1. This means blue and green must add up to 0.1. But we're told in the question the number of blue cubes is the same as the number of green cubes, so their probabilities must be the same. So we can take 0.1 and split it in half. If you do 0.1 divided by 2, you get 0.05. So the probability for blue is 0.05, and it's the same for green. In the second part of the question, Kim claims that there are 75 cubes in the box, and we need to explain why Kim must be incorrect. Well, if we know there are 75 cubes in the box, we can multiply 75 by each of the probabilities to work out how many cubes there are of each colour. So if we do 75 times 0.8 for red, this gives us 60. If we do 75 times 0.1 for yellow, it's 7.5. And for blue and green, it would be 75 times 0.05, which is 3.75. So if there were 75 in total, there would be 60 red, 7.5 yellow, but 3.75 blue and green. Now clearly that doesn't make sense because the number of cubes of each colour needs to be a whole number, an integer. So we can now say the number of each colour must be an integer. And that concludes the question. In this question, we've been told the interior angle of a regular polygon is 168, and we need to work out the exterior angle. If we draw a picture of what this shape might look like, one of the angles would look like this, where this is the interior angle of 168. To get the exterior angle, we draw this line on, and this angle here is the exterior angle. You can see that both of these lines add together to make 180 degrees, so we just do 180 take away 168, which gives you 12 degrees. In the second part of the question, we need to find out how many sides this polygon has. To work out the number of sides of a regular polygon, you just do 360 divided by its exterior angle. We worked out the exterior angle in the first part, that's 12, so we do 360 divided by 12, which gives you 30 sides as the answer. In this question, we've been given a table of values, but we're missing some of the y values. You can see we have all of the x values here though. What we're going to do is substitute each of the x values into this equation here to give us the corresponding y value. So let's start with x equals negative 2. If x equals negative 2, then we have y equals x squared, which is negative 2 squared, subtract 3 lots of x, which is 3 lots of negative 2, and then subtract 1. You can type this into a calculator and it will give you the answer 9. So when x equals negative 2, y equals 9. Now we can skip over negative 1 and move straight to 0. So we need to do 0 squared, take away 3 lots of 0, and then take away 1. This gives you negative 1. So we can put that into the table as well. Then we move along to x equals 1, we've got 1 squared, take away 3 lots of 1, take away 1, which gives you negative 3. And the final one we need to do is when x equals 4, so we do 4 squared, take away 3 lots of 4, take away 1. And this gives you 3. And that's the table complete. For part B of the question, we need to draw the graph. To do this, we're going to plot each of the points of coordinates. We start with negative 2, 9, which goes here. Then we've got negative 1, 3, which goes here. 0, negative 1 goes here. 1, negative 3 goes here. 2, negative 3 goes here. 3, negative 1 goes here. and 4, 3 goes here. Notice how these points don't form a straight line, instead they form a smooth curve. So we want to draw a nice curve between them, something that looks like this. For the final part of the question, we need to use the graph to estimate some solutions to an equation. If you look at the left-hand side of this equation, you'll see it perfectly matches the equation of the graph. But the right-hand side, however, says 2. This means we need to know when the graph gives us a value of 2. To do this, we can draw on the line y equals 2 and find where these two graphs cross. They cross at these two places here, and we read off their x values. So for the first one on the left, I get about x equals negative 0.8, and for the one on the right, it's about x equals 3.8. There'll be some slight leeway in this answer depending on exactly how you drew that curve. In this question, we need to identify a region where the tower could be placed. We're told first of all it's closer to point C than point D. So what we're going to do is construct the perpendicular bisector of the line from C to D. To do this, you take a pair of compasses and place them on C first of all, and draw yourself a nice big arc, something that looks like this. Then you keep the compasses exactly the same size and draw the same arc but place your compass point at D, so it looks something like this. Once you've drawn both of those arcs, you can connect up their intersections to form this line here. This line is the set of points that's exactly the same distance from C as it is to D. Now since the tower is closer to C than it is to point D, it must be on the left of this red line. The second thing we're told about the tower is it's within 350 meters of point B, and we're given a scale that says that 1 centimeter represents 50 meters. So if we divide 350 by 50, we find that it must be 7 centimeters on our diagram. So the tower must be within 7 centimeters of point B. So what we do is take a pair of compasses, place them at B, set them to 7 centimeters in width, and then draw ourselves an arc there, something that looks like this. So we must be inside this purple arc. So now we can find the region where the tower must be. It must be to the left of the red line, but it must be inside the purple arc, and of course inside the rectangle. So the only region that's viable is this one here. For the first part of this question, we need to find the highest common factor of 75 and 210. To do this, I'm going to write both of those numbers as a product of their prime factors, and we can use a calculator to help with this. So if you take your calculator, let's do 75, you press 75, so 7, 5, then equals, and your calculator will just say 75. But if we now go and press Shift, and then we press this button here, you can see in yellow it says Fact. So if we press this button, it will show us the prime factorization. So it's 3 times 5 squared. So we can now write that 75 is equal to 3 times 5 squared. And 5 squared is just 5 times 5. I'm actually going to separate those out. It will make this question a bit easier to do. Then you do exactly the same thing for 210 using your calculator. Type 210, then press equals, then Shift, then Fact. And it will tell you that 210 is 2 times 3 times 5 times 7. Now we're going to draw a Venn diagram. The left circle will be for 75 and the right one for 210. We're going to look first of all for numbers that are in both of those prime factorizations. I can see we've got a 3 in both of them, so if I cross off this 3 and then put a 3 in the centre. I can see I've also got a 5 in both of them, so if I cross off one 5 from each of them, I can put that into the centre. Now there's nothing else left that matches. In the 75 I've got a 5, and the 210 I have a 2 and a 7. So if I cross off the 5, I can place that in the 75 circle, and if I cross off the 2 and the 7, both of those can go in the 210 circle. Now all we need to do to find the highest common factor is multiply the numbers in the intersection, this part here. So you just do 3 times 5, which is 15, and the answer to the question. For the second part of the question, we need to find the lowest common multiple. We can make use of that Venn diagram once again. To find the lowest common multiple, you multiply all of the numbers you can find in the Venn diagram here. So we need to do 5 times 3 times 5 times 2 times 7. You can see we use all 5 of those numbers. If you do this with your calculator, you'll end up with the answer 1050, the answer to the question. In this question, we're told the volume of the cone is equal to 30% of the volume of the sphere. So let's start by working out the volume of the sphere. We've been given the formula for that. It's the volume of the sphere is 4/3 pi r cubed. So the volume of this sphere is 4/3 times by pi. Then we need to times by the radius cubed. You can see the radius of this sphere is 5. So it's times 5 cubed. Now for the volume of the cone. The volume of the cone is 30% of this. So if we take the volume of the sphere that we had before, and multiply this by a multiplier for 30%, which is 0.3. This is the volume of the cone. If you type this into your calculator, it will come out as 50 pi. We've been asked to work out the height of the cone, h. Imagine we were going to find the volume of the cone. We would use this formula here, which is 1/3 times pi, then times the radius squared. If you have a look at the cone, you can see the radius will be half of 8, which is 4, so times 4 squared. Then we would multiply by the height, but we don't know the height, so we're just going to have to call it h, and then we would get the volume, which we know is 50 pi. So we just need to solve this equation to get the value of h. If you type all of this part here into your calculator, you'll get 16/3 pi. So we have 16/3 pi times h equals 50 pi. At this point, we can divide both sides by pi, which will remove the pi's, so we end up with 16/3 h equals 50. Now multiply both sides by 3. On the left, that will give us 16h, and on the right, 150. Then divide both sides by 16, and you get h equals this number here, 9.375. The question asks us to give the answer to one decimal place, so it's 9.4. In this question, we've been asked to work out the value of x. We've been told that lines BD and AE are parallel. This means we can be sure that this triangle here, which is BCD, is similar to this triangle here, which is ACE. Let's label on any information we know about these triangles. So we know the length from B to D is 6, and we know from C to D is 4. For the larger triangle, we know A to E is 18, and we can also work out the length from C to E by adding CD and DE, so it's x plus 4. Since the two triangles are similar, we know that one of them is a scale factor enlargement of the other one. So if we divided their corresponding sides, we would find we always get the same number. This means if we take CE and CD and divide them, that would give us the same value as if we divided AE by BD. So we end up with this equation here. On the right hand side, if you did 18 divided by 6, you get 3. You can now multiply both sides by 4. On the left, this will give x plus 4, and on the right, it will give 12. Then if we just subtract 4 from both sides, we find that x is equal to 8. And that's the answer to the question. For the second part of the question, we've been asked to write down the value of y. Remember from before, lines AE and BD are parallel. So if we draw those on, but also draw on the line AC here, we can see that angle y will be the same as the angle down here, at 41 degrees. So angle y is also 41 degrees. For the final part of this question, we need to give a reason for the answer to part B, so we need to explain why y was 41 degrees. Since these lines are parallel lines and we end up with this upside down F shape, we need to recognise that these are corresponding angles. So all we would need to say is that corresponding angles are equal. In this question, we've been asked to find the equation of the line. To find an equation of a straight line, you need two bits of information. You need the gradient and the y-intercept. I'm going to start with the gradient. To find the gradient, you need to pick 2 points on the line and draw a gradient triangle. I'm going to go for this point here and this point here. And then I'll draw a gradient triangle between them. It looks like this. You then need to work out what those vertical and horizontal distances are. Vertically, we can see we go from 4 to 1, so that's going down 3. And then horizontally, we go from -2 to -1. So that's across 1. You need to be careful here and not just rely on counting squares. You can see that's 2 squares, but it's only actually 1 on the axis. Then we can work out the gradient by doing gradient equals the change in y over the change in x. The change in y is the 3 that's in the vertical direction, but since we went down, we're going to write -3. And then in the horizontal direction, we went across 1. So the change in x is 1. If you do -3 divided by 1, you get -3. So the gradient is -3. The y-intercept is much easier to find, it's just where the line crosses the y-axis, which is here. So the y-intercept is -2. Now we're ready to form the equation of the line. The general equation of a straight line is y equals mx plus c, where m here represents the gradient and c represents the y-intercept. So all we need to do is write this out again, but instead of m write -3, and instead of c write -2. So it's y equals -3x subtract 2. In this question, we've been asked to show that this equation here is true. In the question, there's a trapezium, and we've been told its area is 24 centimeters squared. So let's work out the area of this trapezium. To do this, we need to use the formula for the area of a trapezium, which is 1/2 of a plus b multiplied by the height. A and b here are the parallel lines, so you can see that's line BC and AD. It doesn't matter which way around we label them, so let's label the top one A and the bottom one B, and then of course this x minus 3 here is the height. So we just need to substitute all of those into the formula. So it's 1/2, and then we need to add a and b together, so I'm going to do quite a big bracket here, and then we're going to put a, which is x plus 1, and then add to this b, which is x plus 3. So that's the a plus b part done, and then we multiply this by the height, which we can see is x minus 3. So this is multiplied by x minus 3. Now this is an expression for the area of the trapezium, which we know must be equal to 24 because it tells us so in the question. The next thing we want to do is look at this bracket here. We can do some simplification. If you add x and 1 and x and 3, you get 2x plus 4. So instead we can write this as 1/2 of 2x plus 4 times x minus 3 equals 24. Next I'm going to multiply this half by the first bracket here. If you do half of 2x plus 4, you get 1x plus 2. So it's x plus 2 times x minus 3 equals 24. We can now expand the double bracket. So let's do x times x, that's x squared. X times negative 3, that's negative 3x. 2 times x, that's plus 2x. And finally, 2 times negative 3 is negative 6. And all of this equals 24. We can simplify the left-hand side. Negative 3x plus 2x is negative 1x. So we've got x squared, subtract x, subtract 6, equals 24. Now we just need to subtract 24 from both sides. If you do this on the left, you get x squared minus x, and then we need to take 24 from negative 6, which is negative 30, and on the right-hand side, 24 take 24 is 0. And you can see we've ended up with what they asked us to in the question, so we've shown it. In the second part of this question, we need to work out the value of x. So let's return to that equation we had before. We need to solve this. We can do this one by factorising. If you factorise on the left-hand side, you get x takes 6, x plus 5, and then on the right-hand side equals 0. This leads us to two solutions. Either the first bracket equals 0, so x minus 6 equals 0, or the second one does, so x plus 5 equals 0. If you solve both of these, you end up with x equals 6, or x equals negative 5. Now, whilst this equation does have two solutions, only one of them is valid in the context of this question. Remember, the lengths of this shape are x plus 1, we've got a height of x minus 3, and then on the bottom we have x plus 3. So let's imagine that x was equal to 6. What would happen? Well, on the top here we do 6 plus 1, which is 7, and then for the height it will be 6 minus 3, which is 3, and then on the bottom 6 plus 3, which is 9. That all looks okay. But if it was x equals negative 5, we do negative 5 plus 1, which is negative 4, negative 5 subtract 3, which is negative 8, and negative 5 plus 3, which is negative 2. Now clearly we can't have a length that's negative, so we're not going to include the x equals 5 solution. So the answer to x is x equals 6. In this question, we're told the probability that she wins the 200-meter sprint is 0.9. This means the probability she does not win the sprint is 1 take away 0.9, which is 0.1. So we can complete the first part of the tree diagram by putting a 0.1 for the probability that she does not win the 200-meter sprint. Next, we're told the probability she'll win the long jump is 0.8. This means the probability she does not win the long jump is 1 take away 0.8, which is 0.2. So we can now complete the long jump section of the probability tree diagram. It's 0.8 for win, and 0.2 for does not win, and the same for the bottom branch, 0.8 and 0.2. In the second part of the question, we need to work out the probability she wins exactly one of the events. So she's going to win one of them, but not win the other one. There are two ways that this could happen. First of all, she could win the 200-meter sprint, but then not win the long jump. When we move across a tree diagram like this, we multiply the probabilities. So we need to do 0.9 multiplied by 0.2, which is 0.18. Now the other option is for not winning the sprint, but we do win the long jump. So 0.1 times 0.8, which is 0.08. We then just add these two probabilities together. 0.18 plus 0.08 is 0.26, and that's the answer to this part of the question. In the first part of this question, we've been asked to work out the coordinates of the point D. We've been told that point M is the midpoint of AB and CD. Since we know the coordinates for A and for B, we can work out the coordinates of M by finding its midpoint. To find the midpoint of 2 points, you just find the average of their corresponding coordinates. So if you look at point A, the x-coordinate is 4, and for point B, the x-coordinate is 10. So if we do 4 plus 10, and then divide this by 2, we end up with 14 over 2, which is 7. This tells us the x-coordinate of the midpoint is 7. If we now do the same for the y-coordinates, the y-coordinate of A is 10, and the y-coordinate of B is 2, so we just need to add those, 10 add 2, and divide this by 2. This time it's 12 over 2, which is 6. So we know the coordinates of M are 7, 6. Next, we've been told in the question that the line segment CM is parallel to the x-axis, and that point C is on the y-axis. If CM is parallel to the x-axis, we know it's a horizontal line. And since C is on the y-axis, points C and M must both have the same y-coordinate. So we know the y-coordinate of C must also be 6, and since it's on the axis, its coordinates are 0, 6. Now remember that M is also the midpoint of the line CD. So this distance here, which we can work out is 7, since the x-coordinates go from 0 to 7, must be the same as this distance here. So that must also be 7. So if you add 7 and 7, you get 14, which means the x-coordinate of D must be 14. We know the y-coordinate is going to be 6, since that's a horizontal line, so the coordinates of D are 14, 6. And that's the answer to the first part. In the second part of the question, we need to prove that two triangles, AMC and DMB, are congruent. There are a few different ways of showing that triangles are congruent, but for this one I'm going to use the rule SAS, which stands for side, angle, side. The first thing I'm going to write down is that CM is equal to MD. That was the blue lines we had earlier. We know this is true since M is the midpoint. We also know that M is the midpoint of the line AB, in which case AM is the same length as MB, once again because M is the midpoint. Next we're going to look at this angle here, angle AMC. This is the same size as this angle over here, angle BMD. We can be sure that angle AMC equals angle BMD because they're vertically opposite angles. We've now written down enough information to show that these two triangles must be congruent. We've found two pairs of corresponding sides which must be the same length, and also the angle in between them. So we can write down that triangle AMC is congruent to triangle DMB due to SAS, which means side, angle, side. For the first part of this question, we need to find the coordinates of the turning point of the graph. The turning point is right at the bottom of the graph here, so the coordinates for that one are -1, -3. For the second part of the question, we need to write down the equation of the line of symmetry. You can see the line of symmetry goes here. The equation of this line that cuts the x-axis at -1 is x equals -1. For the final part of the question, we need to write down estimates for the roots of this equation. Since this equation matches the graph that's been drawn, and it equals 0, we're looking for where this graph crosses the x-axis. There are 2 points where this is the case, so we've got one here and one here. If we read off those x values, for the first one it's x equals -2.7, and the second one x equals 0.7. In the first part of this question, we're told that y is directly proportional to x. This means to get from y to x, we're always multiplying by the same constant number. So we just need to work out what that is. If we look at the first set of values here, we have a pair. To get from 1 to 4, you're just multiplying by 4. So for the second set of values, when y is equal to 80, we can multiply 80 by 4 to get 320. Now for the next two missing values, we're actually going backwards. We're going from x to y, in which case we need to reverse this and divide by 4 instead. 10 divided by 4 is 2.5, and 0.5 divided by 4 is 0.125. For the second part of this question, we've been asked to sketch a graph of P against Q, and we've been told that P is inversely proportional to Q. If two variables are inversely proportional to each other, their graph would look something like this. The key point to understand here is that this is a nice smooth curve, but it's never going to touch either of those axes. It will get closer and closer and closer, but will never actually get there. So make sure when you sketch yours, it doesn't touch the axis. Now this isn't the answer to the question, but you may find it useful information. If the question said directly proportional rather than inversely proportional, You draw a straight line that goes up like this, and it must go through the origin. In this question, we need to match some equations to their corresponding graphs. Let's start with the first one, y equals negative x squared. An x squared graph is always going to give a u-shape or an upside down u-shape. But since this one is a negative x squared, it's actually the upside down u-shape, which is graph f. Then we move on to y equals x cubed. There are two graphs that give cubic shapes, graph E and graph I. We just need to decide which one it is. You can do this by substituting in some values. Let's think about what happens if we cube a positive number. Like if we cube 2. If we cube 2, we get 8. What if we cube negative 2 though? That would be negative 2 times by itself and then by itself again, which would give negative 8. So we can tell it must be graph E, because when you substitute x as a positive number, you get y as a positive number. And when you substitute x as a negative number, you get y as a negative number. So it's graph E. For the next one, you need to learn your trigonometric graphs. There are two that it looks like it could be graph A or it could be graph D. When you do sine of 0, you get 0, which means this one must go through the origin, so it must be graph D. Graph A was actually the graph of cos of x. And finally, we need to do 1 over x, which could be graph C or graph G. These are both reciprocal graphs. But again, this one, if you think about positive values, if you do 1 over a positive value, you get a positive value back. And the same idea for negatives. 1 over a negative value will give you a negative value. So it must be graph G. Graph C would be y equals negative 1 over x. In this question, we've been asked to work out the mass of the cuboid in kilograms. We've been given a ratio, it's the volume of gold in the cuboid to the volume of silver in the cuboid. So let's work out the total volume of the cuboid. To find the volume of a cuboid, you just need to multiply all of those lengths together, 30 times 8 times 6, which is 1,440. Now that we know the total volume, we can split it into the volume of gold and volume of silver using that ratio. In the ratio, there are 3 parts gold, 5 parts silver, so 3 plus 5 gives 8 parts in total. So if we split this total volume into 8 parts, we do 1,440 divided by 8, which gives you 180. So every one part of the ratio is 180. Since there are 3 parts for gold, we multiply 180 by 3, which gives you 540. And since there are 5 parts for silver, we're going to do 180 multiplied by 5, which is 900. So we now have the volume of gold and volume of silver in the cuboid. We've also been given their densities in the question. So we can use this to work out the mass of gold and the mass of silver. We can use the formula mass equals density times volume. Let's do this for gold first. So the mass of gold is the density of gold, which is 19.3, times the volume of gold, which is 540. This gives you this number here. Then we'll do the same for silver, so mass of silver, the density of silver, that's 10.5, times by the volume of silver, which is 900, gives you this number here. We can add those two together to get the total mass of the cuboid, which gives you this. And the question does say to give it in kilograms, so we need to divide that by 1000, which is 19.872. It also says give it to 3 significant figures though, so we're going to round this to 19.9 kilograms. And that's the answer to the question. In this question, we need to work out the length of one of the sides of the cube. We've been given this formula, pressure equals force over area. So let's have a read of the question and see what information we have been given. We've been told the force, that's 320 newtons, and we've also been told the pressure. The pressure is 500 newtons per meter squared. So we can rearrange this formula to work out the area. The area would be the force divided by the pressure. So if we take the force from the question, 320 newtons, and divide that by the pressure, we end up with 0.64 meters squared. So we found the area as 0.64 meters squared. That's specifically the area of the face that's in contact with the ground. So this one here. Now in the question we're told this is a cube. A cube has all of the sides the same length. So if we just want to work out the side length of this cube, we can square root 0.64 to get 0.8. This works because 0.8 times 0.8 would give you the area of that square on the bottom, 0.64. So the answer to this question is 0.8 meters. In this question, we need to show that lines L1 and L2 are parallel. Parallel lines have the same gradient, so we're going to find the gradient of both of these lines and hope they're the same. Let's start with line L1, this one here. So if we take this equation, it's much easier to see its gradient if we write it in the form y equals mx plus c. So we're going to rearrange it to get y as the subject. Let's first of all add 8x to both sides. This will give us 2y on the left, and on the right 10 plus 8x. Then divide both sides by 2, this gives you y equals, divide 10 by 2 and 8x by 2, that's 5 plus 4x. Which we could also reorder as y equals 4x plus 5. Now it's in the form y equals mx plus c. You can see the gradient really clearly is the number in front of the x, which is 4. So the gradient of line L1 is 4. Now let's move on to the second line. We've not been given its equation this time, but we have been given 2 coordinates from the line. We can find the gradient of this using the formula gradient equals change in y over change in x, which some people write as y2 over y1 minus x2 over x1. In this case, y1 is the y coordinate of the first point, and y2 is the y coordinate of the second point. x1 is the x coordinate of the first point, and x2 is the x coordinate of the second point. So we just need to substitute these points in. So y2 minus y1 would be 30 minus 10, and x2 minus x1 would be 8, subtract 3. 30 take 10 is 20, and 8 take 3 is 5, so this is just 20 over 5, and 20 divided by 5 is 4. So we've also found the gradient of line L2 now, that's also 4. Now we can just write a concluding statement. Lines L1 and L2 have the same gradient, so they are parallel lines. In this question we have a Fibonacci sequence, and we've been told some information about the fourth and fifth terms. So let's work out the fourth and fifth terms of the sequence. To work out the next term of a Fibonacci sequence, you add together the previous 2 terms. So if we're going to work out the fourth term, we need to add the second and third terms together. That's these 2 here. So if we added those together, we'd do 2b plus 3a plus 2b. And if you simplify this, you get 3a plus 4b. So that's the fourth term. Then to get the fifth term, we would add the third and fourth terms together. That's these 2. So we do 3a plus 2b plus 3a plus 4b, which would give you 6a plus 6b, and that's the fifth term. Now we can return to these statements. We've been told the fourth term is equal to 51 and the fifth term is equal to 84. If we write that down algebraically, it's the fourth term, 3a plus 4b, equals 51, and then the fifth term, 6a plus 6b, equals 84. These are some simultaneous equations we can solve. I'm going to double the first equation to make the a's match. If I double the first equation, I get double 3a, which is 6a, double 4b, which is 8b, and double 51 is 102. I can now subtract the equations. 6a take away 6a is 0, 8b take away 6b is 2b, and 102 take away 84 is 18. Divide both sides of this by 2 and you find that b is 9. We can now find the value of a by substituting this back into one of the equations. I'm going to go for the second one here. So we have 6a plus 6 lots of b, but we know b is now 9, equals 84. 6 9s are 54, so we've got 6a plus 54 equals 84. Subtract 54 from both sides and you get 6a equals 30. Divide both sides by 6 and you find that a is equal to 5. So we found the values of a and b. A was 5 and b was 9. In this question, we've been told that ABCDE is a pentagon, and since we're dealing with its interior angles, we're going to work out the interior angle sum using this formula here, where n is the number of sides. Since a pentagon has 5 sides, we do 5 take away 2 times by 180, which is 540. We'll come back to that in a moment. Now we've been told that x to y is in the ratio 1 to 6. This means that y is 6 times bigger than x, which we could write as y equals 6x. So we can replace all of the y's in the question with 6x like this. Now let's return to that 540. That's the sum of all of the angles in the shape. So if we added up all of the angles, we've got the 2 x's, x plus x, and then we've got the 3 y's, but we just replace those with 6x. So it's plus 6x plus 6x plus 6x equals 540 degrees. We can simplify the left side of this. If you add up all of those x's, you get 20x equals 540, and then divide both sides by 20. You find that x is equal to 27. In this question, we need to find x and y though, but remember y was equal to 6 lots of x. So if you just multiply x by 6, you need to do 6 times 27, which gives you 162. So x is 27, and y is 162. In this question, we're trying to find the length of the arc DEF, I'm going to mark this arc onto the diagram so you can see it, it's this one here. To find the length of an arc, we use the formula arc length equals theta over 360 multiplied by pi and multiplied by the diameter. So we just need to find the angle for this sector theta and also its diameter. Let's start with the angle. The angle we want to find is this red one here, but we can't find that straight away. Instead, we're going to find this blue angle here first. We're going to look more closely at the triangle AFG, which looks like this. You can see its hypotenuse is 10 and one of the other sides is 5. And the angle we're after is in the bottom right, so let's call that x. We can find this using trigonometry. The 5 is the opposite and the 10 is the hypotenuse, so we can write down that sine of x equals the opposite, which is 5, over the hypotenuse, which is 10. To find x, we would write x equals and then do inverse sine of 5 over 10, which will give you 30 degrees. So we found this blue angle at 30 degrees, we can add that onto our diagram. Now if we look more closely at the top sector, we can see that lines AG and CG are both a radius for that sector, so the line CG must also be 10. This means that the triangle on the right hand side is actually congruent to the one on the left hand side, so we can be sure that this angle in here is also 30 degrees. Now we found all of the angles in that circle apart from the red one, so if we subtract those from 360 we'll find the red one. So 360, take away the 230s and take away the 80, will give you 220. So we found the angle for that sector, which is 220 degrees. We can replace the theta in the formula with 220. Now let's try and find the diameter. We're going to find the diameter by first of all finding the radius. The line FG here is a radius of the circle, so we can try and find that line. We already drew out the triangle AFG earlier, so the line we're talking about is this one here. We can find that length using Pythagoras. So if we imagine it's called r, we could write that r squared is equal to 10 squared take away 5 squared. Square rooting both sides of this will give you r is equal to square root 75. So if the radius is square root 75, the diameter must be double this, so the diameter must be 2 root 75. We can now replace the diameter in the formula with 2 root 75, and all of this can be typed straight into a calculator, and it'll give you this number here. So we found the arc length, it's this number. The question wants us to give it to one decimal place, so we'd round it to 33.3, which is the answer to the question. In this question, we've been asked to draw a box plot using the information that's given in the stem and leaf diagram. To draw a box plot, you need 5 bits of information. We're going to start with the minimum and maximum values. The minimum value in the stem and leaf diagram is this one here, which is 9, and the maximum one is this one here, which is 31. So we need to draw a vertical line at 9 and another one at 31. Next, we need to find the median and the lower and upper quartile. Notice in the question we have information about 23 mobile phones. So we do 23 plus 1, which is 24, and then divide this by 2, which gives you 12, and this tells you the 12th value is the median one. If we divided 24 by 4 instead of 2, we would get 6, which means the 6th value is the lower quartile. Let's go and find those, and then we'll come back and do the upper quartile last. So if we count through the data in order, when we get to the 6th value, that will be the lower quartile. So let's cross off the 1st, 2nd, 3rd, 4th, 5th, and then the next one must be the 6th, so that one there is the lower quartile. So that's 13, so let's draw a line at 13. Then if we keep going until we get to the 12th one, that's the median. So the 7th, 8th, 9th, 10th, 11th, and there we go, there's the 12th, that's 19. So we need a line at 19. Now we just need the upper quartile. To do this, you can take the 6, which we got for the lower quartile, multiply it by 3, and this will tell us it's in the 18th position. Now there are 2 ways of doing this. You could either count through until you get to the 18th one, or you could just count backwards 6 from the end, like this, 1, 2, 3, 4, 5, and then the next one is 6. So the upper quartile is 27, we draw a line at 27. We connect together the lower quartile, the median, and the upper quartile to form this box, and then we connect up the lowest and the greatest value to those boxes with horizontal lines like this. And there's your completed box plot. In the second part of the question, we've been asked to compare the distribution of battery lives for company A and company B. To do this, we'll make 2 comparisons, one about the median and one about the interquartile range. Let's start with the one about the median. So the median for company A is this line here, which is 19 hours, and the median for company B is this line here, which is 17 hours. So the median battery life in hours was higher for company A than it was for company B. So we could write, the median battery life for company A was higher, and then we need to explain what this means in context. In context, this means their batteries lasted longer on average. The phrase on average is particularly important here to make sure you get the marks. It doesn't mean every battery will last longer for company A compared to company B, but the average battery will. Next, we're going to look at the interquartile range. To do this, we need to do the upper quartile, subtract the lower quartile for each one of the companies. Let's do it for company A. You can see the upper quartile here, that's 27, and the lower quartile here, that's 13. So for company A, we need to do 27 take away 13, which gives you 14. For company B, the upper quartiles here, that's 21, and the lower quartiles here, that's 15. 21 take away 15 gives you an interquartile range of 6. So you can see here, company A also has a larger interquartile range. So we could say, the interquartile range for company A was higher, and then again we need to explain that in context. So in the context of this question, that would mean that their battery lives were more varied. Another phrase you could use here is you could say their battery lives were less consistent. In this question, we've been asked to work out the surface area of this solid shape. This shape comes in two parts. We've got a hemisphere on the bottom and a cone on the top. Let's start with the hemisphere, this part here. We've been given the formula for the surface area of a full sphere, which is 4 pi r squared, where r is the radius. We don't have the radius of this sphere, so we're going to need to work that out, but we do have this length here, which will be the diameter. That's 16. If we half that, we get the radius, so the radius is 8. So if we worked out the surface area of this as though it was a full sphere, it would be 4 times pi times the radius squared, which we just said was 8. And if you type this into your calculator, or work it out, you'll get 256 pi. Now this is for the full sphere, but we only have a hemisphere, so we only have half of that surface area. So if we divide this by 2, you end up with 128 pi. So that's the hemisphere done. Now let's have a look at the cone. For the cone, we need to find the curved surface area, and we've been given its formula up here. It's pi r L, where L is the slant height of the cone. That's this length here. We don't have that at the moment, so we're going to need to work it out. Let's draw on a radius from the center of the cone to the edge, and we create a triangle, which we can draw over here, and we can label on the bits we know. We know the base is 8, since that's the radius, and we also know the height that's on the diagram, that's 15. And L is this one here, the one we're trying to find. We can find this using Pythagoras. So we could say that the hypotenuse, which is L squared, is equal to 15 squared plus 8 squared, and then if we square root both sides of this, we find that L is equal to square root 289. And if you do this, you'll end up with 17. So we found that L is 17, we're now ready to use the formula. The formula was pi r L, so we need to do pi times the radius, which is 8, times L, which is 17. This gives you 136 pi. We're now ready to finish the question. To get the total surface area of the whole shape, we just add together the two surface areas we found, 128 pi and 136 pi. If you add these together, you end up with 264 pi. If you type 264 pi into your calculator and convert it to a decimal, you get this number here. The question asks us to round it to 3 significant figures, so the answer will be 829. You may be wondering why we didn't include the circular parts of the surfaces of those shapes. Since the cone and the hemisphere are attached together, the circle parts aren't actually on the outside surface of the shape, so we don't need to include those. If you were doing the surface area of just the cone though, or just the hemisphere, you would need to work out the circle as well and add that on. For this question, we need to expand and simplify some triple brackets. To do this, we're just going to expand the first two brackets first. So if we expand x plus 9 times x plus 2, we do x times x, which is x squared, x times 2, which is plus 2x, 9 times x, which is 9x, and 9 times 2, which is plus 18. So if you expand the first two brackets, we end up with this. We can simplify these two terms here to get x squared plus 11x plus 18. So we can now replace both of those first two brackets with this quadratic x squared plus 11x plus 18. So the question is actually x squared plus 11x plus 18 times by x minus 3. Now we need to multiply everything in the first bracket by everything in the second bracket. So we do x squared times x, that's x cubed, x squared times negative 3, negative 3x squared, 11x times x, that's 11x squared, 11x times negative 3, negative 33x, and then 18 times x, that's plus 18x, and finally 18 times negative 3, negative 54. There's a bit more simplifying to do, so we've got x cubed at the front, Then we've got two terms here in x squared. Negative 3x squared plus 11x squared is plus 8x squared. We've also got two terms in x. We've got negative 33x plus 18x. That's going to give you negative 15x. And then finally negative 54 at the end. And that's your answer to this question. In the first part of this question, we need to work out the value of 16 to the power 1/2. Whenever you raise any number to the power of 1/2, you just need to find the square root of it. So we need to do the square root of 16, which is equal to 4. In the second part of this question, we need to work out 25 over 4 all to the power 0. Any number to the power 0 is always equal to 1. So it doesn't matter that it says 25 over 4 there, the answer to this question is 1. In the final part of this question, we've been told that 4 to the power n equals 8. We need to work out 100 to the power negative n. To do this, we're going to try and work out the value of n first. So if we start with this 4 to the power n equals 8, we're going to try and write both the left and right hand side as a power of 2. The number 4 is the same as 2 squared, so we can rewrite the left hand side as 2 squared all to the power n. And on the right hand side we have 8, which is equal to 2 to the power 3. On the left hand side here we can use the bracket to a power law. To do this we just multiply the indices, so this is equal to 2 to the power 2n, since we do 2 multiplied by n. And on the right hand side we'll still keep 2 to the power 3. You can now see we've written both of the sides as a power of 2. Since both sides are in this form, we can see the indices must be equal. So 2n here must be equal to 3. If 2n is equal to 3, you can divide both sides by 2, and you find that n is equal to 3 over 2. Now that we know the value of n, we can work out 100 to the power negative n. So since n is 3 over 2, this is 100 to the power negative 3 over 2. When we raise something to a fractional power like this, we look at the denominator, which is this 2, and that tells us what root we need to do. A power 2 there means to do the square root. Once we found this, the power 3 on the top tells us to cube it. So this is like doing the square root of 100 and then cubing it. But we've also got this negative power here, which means we need to take the reciprocal. So instead of this being the answer, it's actually 1 over this. Now we can work this out. The square root of 100 is quite straightforward, that's 10. So on the bottom we have 1 over 10 cubed, and then 10 cubed is 1000. So it's 1 over 1000. For this question, we need to do an enlargement. The first thing to do is mark on the centre of enlargement, which is at negative 2, 1. So let's put a cross there. Then we're going to pick the first point on the shape that we're going to map. It doesn't matter which one you go for, but I'm going to go for this one here. Now in the question it says the enlargement must be scale factor negative 2. When you do a negative scale factor enlargement, you start at your point and work out how you get from your point to the centre of enlargement. So you can see to get from the red cross to the black cross, I just need to go down 4 squares. Since the scale factor is negative 2, I then do this journey 2 more times, but go beyond the centre of enlargement. So if I went down 4, to do this journey 2 more times, I'd need to go down 8. So if I go down 8 from the centre of enlargement, I end up down here. So this is where the red point would map to. Now let's pick another one. Let's go for this one here. So to get from this point to the centre of enlargement, I'd go this way, which is 1 to the right and 2 down. But I need to do this journey 2 more times from the centre of enlargement. So I need to go 2 right and 4 down. That would take me to here. So this is where the green point goes. And finally, let's do the last one. So to get from this point to the centre of enlargement, I need to go this way, which is 3 right and 4 down. And I need to do this 2 more times. So I need to go another 6 right and 8 down. If I go 6 right and 8 down from the centre of enlargement, I end up here. Now that we've drawn all 3 of the points, we can connect them up to make the triangle. It says to label this one B, so we'll do that as well. In this question, we need to draw some inequality regions. The first thing you should know about this is if we have either of these symbols greater than or equal to or less than or equal to, the lines we draw must be solid lines. If it's greater than or less than, they must be dotted lines. You can see in this question, it's always greater than or equal to or less than or equal to, so we'll draw solid lines in all of the cases. We're going to start with y is greater than or equal to 0. To help us draw this, we're going to draw y equals 0 instead. The line y equals 0 is a horizontal line that crosses the y-axis at 0. It's actually just the x-axis, this line here. Now we're interested in all of the points where y is greater than 0, so that would be everything above this line. But at first this might seem counterintuitive, we're going to shade out everything we don't want. So we're going to shade out everything below the line, leaving the points we do want above the line. So it would look something like this. Now we'll move on to the next inequality, is x is greater than or equal to -1. To help us with this inequality, we're going to draw x is equal to -1. This is a vertical line that goes through -1 on the x-axis. It looks like this. Now if we want when x is greater than or equal to -1, we'd need all of the points to the right of this line. But once again, we're going to shade out the area we don't want. So we don't want everything to the left of this line, so we're going to shade this part as well. Then we move on to the line y is less than or equal to x plus 3. To help us do this one, we're going to plot y equals x plus 3. There are a number of ways of doing this, it doesn't matter as long as you end up with the right line. I like to try and substitute in points to work out a few coordinates, specifically when x or y are equal to 0. So let's first of all imagine that x is equal to 0. If x is equal to 0, then we can substitute 0 into this equation here. So it would say y equals 0 plus 3, which of course is 3. So the value of y is 3. So if x is 0 and y is 3, that's the coordinate 0, 3. Now let's also consider when y equals 0. If y is equal to 0, then it would say 0 equals x plus 3, in which case x must be -3. So we end up with the point -3, 0. If we plot both of these points onto the diagram, like this, we can draw a straight line between them. So this is the line y equals x plus 3. Now the inequality says y is less than or equal to x plus 3, so we're interested in the points below the line. So once again, we're going to shade out the points we don't want, which are those above the line. So it will look something like this. Then we move on to the final inequality. To help us do this one, we're going to draw the line 2x plus y equals 6. Once again, we're going to consider what happens when x and y are equal to 0. So let's do x equals 0 first. If we substitute x equals 0 into this, it would be 2 lots of 0, which is 0, plus y equals 6, in which case y is equal to 6. If x is equal to 0 and y is equal to 6, that's the coordinate 0, 6. Now let's have a look at when y equals 0. If y equals 0, we get 2x plus 0 equals 6, in which case 2x equals 6. Divide both sides of this by 2, and you find that x is equal to 3. So we end up with a point 3, 0. Let's plot both of those. They go here, and draw a straight line between them. Now in this one again, it says 2x plus y is less than or equal to 6, so we would like the points below this line. So we're going to shade out the points above the line, something like this. Now because we consistently shaded out the areas we don't want, the area that's left is the area we do want. So we can label this region in the middle here R. That's the region of points that satisfies all of these inequalities. In this question we have Kenny who catches 350 fish from a lake. Kenny's going to mark each of those fish and then return them to the lake. The next day, he catches 175 fish from the lake and he finds that 70 of these fish have been marked. We need to work out an estimate for the total number of fish in the lake. This topic is called Capture-Recapture, and it relies on the idea that the proportion of fish that are marked on the second sample on the next day is the same as the proportion of fish that are marked in the entire lake. Let's write down the proportion of fish that are marked in the entire lake. We know 350 of the fish have the mark, and this is out of a total of all of the fish in the lake. That's the number we're trying to find. We don't know this, so we'll call it x. This is going to be the same as the proportion of fish that are marked in the second sample. In the second sample, we catch 175 fish, and 70 of them are marked. So the proportion that are marked here is 70 out of 175. We can solve this equation by cross-multiplying first. We're going to multiply both sides by 175 and x. This will give us 350 times 175 equals 70x. You can then divide both sides by 70, and we get 350 over 175 divides 70 is equal to x. You can just type this straight into your calculator, and it gives us the answer of 875. For the second part of the question, Kenny returns all of those marked fish back to the lake, and the next day he catches yet another 175 fish. But this time he ends up with a different estimate. We ended up with the estimate of 875, but this time Kenny's going to estimate that there are fewer than 700 fish in the lake. We need to work out the lowest possible number of marked fish that Kenny could have caught. So when we did part A, we ended up with this calculation here. This time the 350 is still the same, there's still 350 marked fish, and the 175 is still the same, we've still caught 175 fish. The question is how many were marked. So we need to change the number 70 and see what happens to the answer. If we increase 70, and just assume for a moment that 71 of those fish were marked, this would change the answer from 875 to 862.676. If we increase it once again, this changes the answer to this, and we need to keep doing this until we get the answer to be below 700. Now it does take a while to get this number below 700, so I'm going to miss a few out and jump to 87, which gives you the answer 704, but we need it to be below 700, and if you go to 88, it does go below 700 at 696.02. So the answer to the lowest possible number of marked fish that Kenny could have caught is 88. In this question, we need to write the numbers in order, starting with the smallest. If we look at the first number here, 2.03 to the power 6, that's going to be relatively close to 2 to the power 6. We can work out 2 to the power 6 easily. It's 2 times 2 times 2 times 2 times 2 times 2, which would give you 64. For the second one, 7.95 squared, that's going to be a little bit lower than 8 squared, and we can work out 8 squared easily. 8 squared is also 64. For the third one, square root of 6,500, that'll be a little bit bigger than the square root of 6,400. The square root of 6,400 is easy enough to work out. That's going to be 80, since 80 times 80 is 6,400. And for the final one, the cube root of 124,000 is going to be a little bit less than the cube root of 125,000. The cube root of 125,000 is going to be 50, since 50 times 50 times 50 is 125,000. So if we now look at each of these numbers in turn, this one's going to be a little bit bigger than 64. This one's going to be a bit smaller than 64. This one's going to be a bit bigger than 80. And this one's going to be a bit less than 50. We can be sure then that the smallest one's going to be the cube root of 124,000. Then it's going to be 7.95 squared. Then it'll be 2.03 to the power 6. And finally the square root of 6,500. In this question, we've got a manager who's going to select one player from each position to win an award, and we need to work out the number of different possible ways there are of picking a goalkeeper, a defender, a midfielder, and a striker. To answer this question, we just need to multiply the number of goalkeepers, which is 3, by the number of defenders, which is 8, by the number of midfielders, which is 10, and the number of strikers, which is 5. If you multiply all of these together, you get the answer 1,200. In this question, we need to sketch the graph of y equals cos of x, for x in between 0 and 360. The graph of y equals cos of x goes between -1 and 1 on the y-axis, so let's mark those on first. Then we need to mark on some key points to help us draw this graph. When you do cos of 0, you get 1, so we can plot the point 0, 1. When you do cos of 90, you get 0, so we can plot 90, 0. Cos of 180 gives you -1. Cos of 270 also gives you 0, and cos of 360 gives you 1. So we need to connect these up with a smooth curve that looks something like this. For the first part of this question, we need to complete a cumulative frequency table. For the first group, the money spent is between 0 and £20. And you can see we actually have that value in the table above as well. So the frequency will be the same as the cumulative frequency, it's this number here, 6. So we can write 6 into our table. The next group is from 0 to £40. This means we need all of the people that spent between 0 and £20, and also the people from 20 to £40. So that's these 16 people here. So if we add both of those together, 6 plus 16 is 22. Then we can continue down the cumulative frequency table by adding in the next frequency each time. So if we add in 29 as well, now we've got 6 and 16 and 29, that gives us 51. And for the final group from 0 to £80, we need all of the frequencies. If you add all of those up, you get 60. For the second part of the question, we now need to draw the cumulative frequency graph. When you draw a cumulative frequency graph, you're going to plot the points at the end of each of the intervals. So we're going to plot them at 20, 40, 60, and 80. And we'll use the cumulative frequencies we just found. So for the first one, at the end point of 20, we need to plot a cumulative frequency of 6. So that goes here. Then we've got an end point of 40 with a cumulative frequency of 22. That goes here. Then an end point of 60, cumulative frequency 51. And finally the end point of 80 with a cumulative frequency of 60. We can now connect up these points either using straight lines like I've done here, or you could draw a smooth curve between them. Both will be fine in your exam. I would recommend doing straight lines just because I think it's easier to do. For part C of the question, we need to use the graph to find the estimate for the median amount of money spent in the supermarket by the 60 visitors. Since the cumulative frequency goes up to 60, we'll find the median at the 30th value. So if you go to 30 on your cumulative frequency, that's halfway up the scale, and then go across until you hit the graph. You can then go down from this point here, and then read off the value for the money. I get the answer of £45.50 since I'm halfway through that square. For the final part of the question, we've been told that one of these 60 visitors is going to be selected to win a prize. And we need to use the graph to estimate the probability that the visitor spent more than £35. So what we can do is look for £35 on the money spent axis at the bottom, go up to the graph, and then read across. We read off the value here of 18. This means that we would estimate that 18 people had spent up to £35. But in this question, they want to know the probability of someone spending more than £35. So we'll subtract these 18 people away from the total of 60, which gives us 42. So we would estimate there are 42 people that have spent more than £35, so the probability of selecting one of them will be 42 over 60. In this question, we have a geometric sequence, and we've been asked to work out the difference between the third and the first term. So if we take the sequence here, if it's a geometric sequence, then to get from the first term to the second term, we must multiply or divide by some number. We just need to work out what that number is. So how do you get from 2 root 5 to 10 root 10? Well, to get from the 2 to the 10, we must multiply by 5, and to get from root 5 to root 10, we must multiply by root 2. So, to get from 2 root 5 to 10 root 10, you multiply by 5 root 2. This means we can work out any term in the sequence if we just keep multiplying by 5 root 2. We need the third term for this one, so let's multiply the second term by 5 root 2. If you multiply 10 root 10 by 5 root 2, you first of all multiply 10 by 5, which is 50, and then you multiply root 10 by root 2, which is root 20. So this is the third term. Now we need to work out the difference between the third and the first term. So let's take the third term, and then subtract from this the first term. So we've got 50 root 20 subtract 2 root 5. But the question wants us to give our answer in the form k root 5. Now at the moment it doesn't look like that form, so what we're going to need to do is convert the root 20 into something that has a root 5 in it. So the 50 root 20 could be rewritten as 50 times square root 4 times square root 5, since square root 4 times square root 5 is square root 20. And then of course we've got take away 2 root 5 at the end. Now this square root 4 here is actually just 2, so we could replace the square root 4 with a 2, and then we could multiply the 50 and the 2 to get 100. So the first term here is actually just 100 root 5. And then we've got this minus 2 root 5 at the end. Now we've got 100 root 5, subtract 2 root 5, that's just 98 root 5. And now it's in the correct form, k root 5, where k is 98. So that's the answer to the question. In this question we have y equals a to the power x, where a is an integer, and we need to work out the value of a. To do this, we're going to substitute in some values for x. Let's start with x equals 1. So when x equals 1, we've got y equals a to the x, so it's y equals a to the power 1. A to the power 1 would just be a, so we end up with y equals a. Now if we look at the graph, specifically the point when x equals 1, that's this one here, you can see that when the x-coordinate is 1, the y-coordinate is 3. Now we said that when x was equal to 1, y was equal to a. And since y is equal to 3, then a must be 3. So we can write down that a equals 3. This also works with the other points if you want to check them. You can see that when x equals 2, that's this point here, we end up with y as 9. And it makes sense because 3 to the power 2, or 3 squared, equals 9. For the second part of the question, we need to complete the graph for x values from 0 to 4. Now they've already done this for when x equals 0, 1 and 2, we just need to do it for when x equals 3 and 4. So we now know the graph is y equals 3 to the power x, since we worked out that a was equal to 3. So when x equals 3, y will be 3 to the power 3, which is 3 cubed, which is 27. Then when x equals 4, y will equal 3 to the power 4, which is 81. So we can now plot these 2 points. We've got x equals 3, y equals 27, that goes here, and also x equals 4, y equals 81, that goes here. This is an exponential graph, so we're going to join it up with a nice smooth curve, something that looks a bit like this. In the first part of this question, we've been asked to draw the graph of x squared plus y squared equals 36. 36 is the same as 6 squared, so we could rewrite this as x squared plus y squared equals 6 squared. You should recognise this as the equation of a circle, where this number here tells you the radius. So in this one, the radius is 6. So we just need to draw a circle which has centre at the origin with a radius of 6. You'll want to use a pair of compasses to do that, and it should look something like this. You'll see it goes through 6 and -6 on each of the axes. For the second part of the question, we need to use the graph to find estimates to these equations here. you'll notice the first equation is the one we drew, and the second equation is the one that they've drawn for us. This means all we're looking for is where these two graphs intersect, and you can see there are 2 points. There's one here and one here. So we need to read off their coordinates. If we start with the one at the top, we've got an x coordinate here and a y coordinate here. The x one's about 1.4 and the y one's about 5.8. And for the second one, we go up here and across here, and we read off the x value about negative 3.8 and the y value about negative 4.6. So there are 2 pairs of solutions to these simultaneous equations. Firstly, we've got the solution where x equals 1.4 and y equals 5.8, and we've also got the solution where x equals negative 3.8 and y equals negative 4.6. In this question, we need to solve a quadratic equation. We've been asked to give our answers to 3 significant figures. This is a giveaway that we need to use the quadratic formula. At the moment, the equation isn't in the correct form for the quadratic formula. We need the right-hand side to be equal to 0. So if we take the equation, you can see we have 2 terms on the right-hand side there, 3x and plus 4. But we would rather the right-hand side was 0. So we're going to subtract 3x and subtract 4 from that right-hand side. And that will mean the right-hand side is equal to 0. But if you do that on the right-hand side, you must also do that on the left-hand side. So we subtract 3x and subtract 4. This will give us 6x squared. Subtract 3x, subtract 4, equals 0. Now it's in the right form. Now the quadratic formula looks like this. This is something you need to memorize for your exam. The letters a, b, and c can be found by looking at the quadratic equation. A is the coefficient of x squared, that's this number 6 here. B is the coefficient of x, that's a negative 3. And c is the constant term at the end, that's negative 4. We now write out what's inside the box, the quadratic formula, but replace each of those letters a, b, and c with their numbers. So we're going to start with x equals negative b. Well, since b is already negative 3, that would switch to a positive 3. So 3 plus or minus the square root of, then we have b squared, which is negative 3 squared. And you can see I put that in brackets because it's a negative number, minus 4 times a, which we know is 6, and then times c, which is negative 4. And once again, I put that in brackets since it's a negative number. And all of this is divided by 2a, so 2 lots of 6. Before typing all of this into the calculator, I like to do a little bit of tidying up. So we're going to write it out again, but simplify a bit. So we have x equals 3 plus or minus, and then we get to the square root. I would type all of this part here into my calculator to see what number it gives me. And if you do that, it will give you the number 105. So it's the square root of 105. And on the bottom, 2 lots of 6 is 12. So we end up with 3 plus or minus square root 105 over 12. We can now separate this into the 2 solutions. We have the version that has a positive and the version that has a negative. So we've got x equals 3 plus square root 105 over 12, and x equals 3 subtract square root 105 over 12. You can now type each of these into your calculator separately, and you'll get the 2 solutions, which are this and this. Now the question did say, remember, give it to 3 significant figures, so we need to round both of these off. So the first one is x equals 1.10, and the second one, x equals negative 0.604. In this question, we need to find the nth term of a sequence. So let's write out the sequence and look at the differences. To get from 8 to 19, you add 11. To get from 19 to 34, you add 15. And if we keep going, it's add 19 and add 23. Since all of these differences aren't the same, we know it's not a linear sequence. So let's check the second differences. What's the difference between 11 and 15? Well, that's plus 4. And it's the same for 15 to 19 and from 19 to 23. When the second difference is constant like this, we know it's a quadratic sequence. We take that second difference and divide it by 2, which in this case gives us 2, and this tells us the coefficient of n squared in the solution. So we know it's going to be 2n squared. What we do now is construct a table like this, pop the sequence at the top, and in the second row we're going to write out the numbers for 2n squared. 2n squared just means 2 lots of the square numbers. So let's start by doing 1 squared, which is 1, and then double this, that gives you 2. Then we do 2 squared, which is 4, and double this, which is 8. 3 squared is 9, and double this is 18. 4 squared is 16, and double that is 32. And 5 squared is 25, and double this is 50. We're now going to subtract the 2n squared from the sequence to leave us with the linear part. So if we do 8 take away 2, that's 6. 19 take away 8, that's 11. 34 take 18, 16. 53 take 32 is 21. And 76 take 50 is 26. So what we're left with at the bottom is the linear part of the solution. This means we can find its nth term relatively easily. We check the differences and you can see it's always plus 5, which means it's 5n, but it doesn't start at 5, it starts at 6, so we need to add 1. So the linear part of the solution is this bit here, 5n plus 1. So if we add the linear part to the quadratic part, we get the answer to the question. The nth term is 2n squared plus 5n plus 1. For the first part of this question, we need to work out the value of f of negative 5. To do this, we're just going to substitute negative 5 into the f function, which is this one here. So the function is x squared minus 3, so we need to do negative 5 squared minus 3. Negative 5 squared is 25, so it's 25 subtract 3, which is 22. For the second part of this question, we need to find the inverse function for h. We can see the function h of x at the top, that's x plus 3 over 4 minus x. So we're going to write that down first of all. Then we swap the h of x for a letter y, and then we swap all of the y's to x's and all of the x's to y's. So instead of y equals, it's going to be x equals, and the two x's will turn into y's. We now need to rearrange this to make y the subject. I'm going to start by multiplying both sides by the denominator of the fraction on the right, 4 minus y. If I multiply the left by 4 minus y, it's x lots of 4 minus y, and on the right the 4 minus y's will cancel, so I've just got the top, y plus 3. We can now expand the bracket on the left hand side. X times 4 is 4x, and x times negative y is negative xy. And this equals y plus 3. Now what we want to do is get all of the terms that involve a y on one side and all of the terms that don't involve a y on the other side. I'm going to do this by adding xy to both sides first. If I add xy to the left, that will cancel the xy that's there, so I end up with 4x. And if I add xy to the right, I've got y plus 3, and then I add xy. Next we're going to subtract 3 from both sides. If we subtract it from the left, it's 4x minus 3, and if we subtract 3 from the right, that'll cancel the 3, so it's y plus xy. Let's take a copy of this and move it up here. We can now factorise the right hand side. So we leave the left hand side alone, and on the right hand side we're going to factorise out the y. So it's y and then a bracket. Inside this bracket would be 1 plus x. We can now just divide both sides by 1 plus x. If we do this on the left, it's 4x minus 3 over 1 plus x. And on the right, the 1 plus x will cancel, so it's just y. You can now replace y back with h inverse of x, and that's the answer to the question. So it's 4x minus 3 over 1 plus x. For the final part of this question, we have to solve an equation. It's gf of x equals f of x plus g of x. So let's work out gf of x first. To work out gf of x, we need to place the whole of the f function inside the g function. To do this, I like to copy out the g function, but replace the x with a bracket. So g of x is 2x plus 1, so I'm going to write 2 bracket plus 1. Then inside this bracket, we're going to place the whole f function. You can see the f function is x squared minus 3, so we're going to write x squared minus 3 inside that bracket. You can expand this bracket. If you do 2 lots of x squared, that's 2x squared, and 2 lots of negative 3 is negative 6, and then we have this plus 1 at the end. We can simplify the negative 6 plus 1 to give us 2x squared minus 5. So that's gf of x. We can now write out the equation. The equation says gf of x equals f of x plus g of x. So we're just going to write out all parts of that. So gf of x first, that's 2x squared minus 5, is equal to f of x, well that's right at the top of the question, x squared minus 3, plus g of x, which is also at the top of the question, plus 2x plus 1. Now we have a quadratic equation to solve. We're going to simplify first on the right hand side. We have negative 3 plus 1, that would be negative 2. Now I'm going to try and get this so that the right hand side is equal to 0. Let's first of all subtract x squared from both sides. If we subtract it from the left, we get x squared minus 5. If we subtract it from the right, the x squared will be cancelled, and it's negative 2 plus 2x. Now we can add 2 to both sides. If we add 2 to the left hand side, we get x squared minus 3. If we add 2 to the right, the negative 2 will cancel, so it's just 2x. Finally, we can subtract 2x from both sides. On the left, this will give you x squared minus 2x minus 3, and on the right, 2x take away 2x is 0. Now that we have it in this form, we can attempt to solve it. This one will actually factorise, so if we factorise the left-hand side, we get x minus 3, x plus 1, and on the right-hand side equals 0. This will give us two solutions. The first bracket gives us x equals 3, and the second bracket x equals negative 1. In this question, we've been asked to draw a histogram. To do this, we're going to add a column to our table. This column's for frequency density. Then we need to work out the frequency density using the formula frequency density equals frequency divided by class width. If we look at the first group in the table, the time goes from 0 to 10. That's a difference of 10, so the class width is 10. So for that one, we do the frequency, which is 23, divided by the class width, which is 10, and we get a frequency density of 2.3. We then do the same process as we go down the table. The next group goes from 10 to 30, that's a difference of 20, so the class width is 20. So we do 34 divided by 20, which gives you 1.7. The next group's from 30 to 35, that's a difference of 5, so 38 divided by 5 gives you 7.6. And on to the final group. This time the class width is 15, and also the frequency is 15, so 15 divided by 15 gives you 1. The next thing to do is label up and scale your axes. The vertical axis is going to be for frequency density, and we can see the maximum there is 7.6, so I need to do a scale that goes up to at least 7.6. So I'm just going to do one big square for each one. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8. That's going to fit nicely. And we should label this axis frequency density. Then along the horizontal axis, we need to put the time. You can see the times in the table range from 0 to 50, so we just need to make sure we go up to 50. This time I'm going to do two big squares to represent 10 minutes. So it'll be 10, 20, 30, 40, 50. And again, we label this axis, this one is time. Now all we need to do is draw a bar for each of the groups in the table up to its frequency density. So the first group goes from 0 to 10 minutes and it has a frequency density of 2.3. So we draw a bar that looks like this. The next group's from 10 to 30 with a frequency density of 1.7. So it looks like this. Then we have from 30 to 35, but the frequency density this time is 7.6. And the final bar's from 35 to 50 with a frequency density of 1. So it goes like this. And there's your completed histogram. There's no need to shade these bars in, I've just coloured them in so it's a bit clearer for you to see. In this question, we're looking to convert 0.136 recurring to a fraction. We're going to start by saying that x is equal to that number in the question, 0.13, and then 6 recurring. Next, what we do is multiply this by 10. If you multiplied x by 10, you'd get 10x. If you multiplied 0.136 recurring by 10, then all of the digits would move one place to the left. So we'd end up with 1.36 recurring. Then at this point we do a check. We're looking to find a pair of numbers where each of the digits that comes after the decimal point matches. So in this one it doesn't match. You can see the 6's all match at the end of the number, but the 3 doesn't match with the 1 and the 6 doesn't match with the 3. So we need to keep multiplying by 10. So we'll multiply it by 10 again. This time we'd get 100x and all of the digits would move one place to the left once again, and we'd end up with 13.6 recurring. We do this check again, and we can check all of those numbers, and we still don't have a perfect match. So we go once more. Now if we multiply by 10 again, we get 1000x, and it will be 136.6 recurring. You can now see that in the top two numbers, every single digit that comes after this decimal point matches. This means these are the two numbers we need. So what we do is subtract them. We do 1000x take away 100x, which would give you 900x, and then we do 136.6 recurring, take away 13.6 recurring. Now all of the 6's match up perfectly after that decimal point, so they will all cancel nicely. So we just need to do 136 take away 13, which is 123. Now if we just divide both sides of this by 900, we find that x must be equal to 123 divided by 900. Now you may remember that earlier in the question the first thing we wrote down was that x was equal to 0.136 recurring, the number in the question. But if x is equal to this fraction, then they must both be equal to each other. So this is the answer to the question. The question does say to simplify the fraction though, so we could divide both of these by 3. You would end up with 41 over 300. In this question we have a quadratic and we need to write it in the completed square form. So we're going to start with x inside a bracket and then all squared, and we also need to put a number inside this bracket. This number will be half of the coefficient of x. If you look at the coefficient of x in the question, it's -8. Half of this is -4. Next what we do is we imagine we expand this bracket, we would get x squared minus 8x, but we would also get a positive 16 from -4 times by itself. So we're going to subtract 16 from this, and then also bring down this positive 19 here at the end. All we do now is simplify the final two terms here. We've got x minus 4 all squared, And then we have negative 16 plus 19, which is a positive 3. You can see it now matches the form they asked for in the question, so the answer is x minus 4 all squared plus 3. For the second part of the question, we've been asked to write down the coordinates of the turning point, and we've been given a graph y equals x squared minus 8x plus 19. Notice how the equation of this graph matches the quadratic expression from the first part of the question. This means that if y is equal to x squared minus 8x plus 19, it must also be equal to x minus 4 all squared plus 3. When it's written in this form, we can find the turning point really easily. The x-coordinate will be the opposite sign of the number that's inside the bracket. So we've got a negative 4 here, so the x-coordinate will be positive 4. The y-coordinate will always be this number outside the bracket, and that's a positive 3, so it's 3. In this question, we're going to select two counters from a bag, and we need to work out the probability that both of them are green. The first line we need to spot in this question is the probability that the first counter is red is equal to 3/5. We're told there are 25 counters in the bag, so at the start of this, 3/5 of those must be red. So let's just work out 3/5 of 25. To do 1/5, you do 25 divided by 5, that's 5, and then to get 3/5, you multiply this by 3, which gives you 15. So right at the start, there are 15 red counters in the bag. So let's imagine we have a bag, and we know it's got 15 red counters in it. Then we need to read this line here. The probability that the first counter is blue and the second counter is red is equal to 1/10. Now we don't know how many blue counters there are, so I'm just going to call that B. So the probability that I select a blue counter on the first pick is B out of the total number of counters, which is 25. Then we've been told we're going to select a red on the second counter, so we would multiply this by the probability of selecting a red. Now the probability of selecting a red will be the number of red counters in the bag divided by the total number of counters in the bag. Now since we selected a blue on the first pick, we can still be sure there are 15 reds in the bag. And then we divide this by the total number of counters. However, it says the counter is not replaced, which means there are now one fewer counters in the bag than there were at the start. So since we've already picked out a blue, there must now be 24 counters in the bag in total. And we know that this is going to equal 1/10. This is now an equation we can solve to find B, which is the number of blue counters. On the left-hand side here, if we multiply those fractions, on the top we have B times 15, which is 15B, and on the bottom 25 times 24, which is 600. And this equals 1/10. You can now multiply both sides by 600. On the left, this will give you 15B, and on the right, 600 times 1/10 is 60. Then divide both sides by 15, and you'll find that B is equal to 4. This means there must be 4 blue counters in the bag at the start. So let's stick 4 blue counters into the bag as well, and now let's focus on green. Since in the question we're told the counters must be red, blue, or green, we can be sure the remaining counters must all be green. So we have 15 red and 4 blue, so we do 25, take 15, take 4, which gives us 6, so there must be 6 green counters in the bag. We're now ready to work out the probability that both counters are green, so we need to select a green on the first go. There are 6 greens, so it's 6 out of 25, and we also need to select a green on the second go, but we've already selected one of the greens, and remember we don't replace that counter, so there are now 5 greens in the bag, and a total of 24 counters. If you multiply these together, you get 30 over 600, which you may simplify to 1 over 20. In this question we have ABCO, which is a sector, and we need to find the area of the shaded region. To do this, we're going to find the area of the whole sector, and then find the area of the triangle and take it off. So let's start with the area of the sector. You can find the area of a sector using the formula theta, which is the angle for the sector, over 360, times by pi, times by the radius squared. You can see the angle in this sector is 125, so let's replace the theta with 125, and you can see the radius for this sector is 11, so let's replace r with 11. You can type this straight into your calculator, and we find the area of the sector is equal to this. Next we need to work on the area of the triangle. Now normally you'd do area of a triangle equals 1/2 times the base times the perpendicular height. But in a question like this, it's much easier to use area equals 1/2 AB sine C, where A and B are the sides either side of that angle, and C is the angle itself. So we can label on here A, B, and C. Now A and B are actually both equal to 11 because they're both the radius of the sector. So we would do 1/2 times A, which is 11, times B, which is also 11, times sine of C, which is sine of 125. If you type this into a calculator, you get this. So all we need to do now is subtract the area of the triangle from the area of the sector. So we do 131.99, take away 49.558 and so on, and we end up with this number here. The question asks us to give it to one decimal place, so if we rounded this off, it's 82.4. In this question, you're going to need to know your exact trig values. So we're going to write this out again, but instead of sines and coses, we're going to work out those numbers. It's important you do this without a calculator. So the value of sine 60 is square root 3 over 2. The value of sine 90 is 1. Cos of 0 is also equal to 1, and cos of 30 is equal to square root 3 over 2. We now just need to expand this double bracket. We'll start with square root 3 over 2 multiplied by 1, which is just square root 3 over 2. Then we come on to square root 3 over 2 multiplied by negative square root 3 over 2. Here we're just multiplying two fractions together. So if we multiply the tops, square root 3 times square root 3, that's just 3, and on the bottom 2 times 2 is 4. So this comes out at negative 3/4. Then we have 1 times 1, which is obviously 1, and then 1 times negative square root 3 over 2, which is negative square root 3 over 2. Now the first and last terms here will actually cancel out, so we're just left with negative 3/4 plus 1, which should give you 1/4, and that's the answer to the question. In this question, we're told that x is directly proportional to y. This means we can write x equals ky, where k is some constant number. We can find the value of k by substituting in this pair of numbers here. So let's replace x with 1 and y with 4. So instead of x equals, it's 1 equals, and instead of k times y, it's k times 4. If you just divide both sides of this by 4, you find that 1/4 is equal to k, or k is equal to 1/4. Now that we found the value of k, we can write that in the formula at the top. So instead of x equals ky, it's x equals 1/4 y. We're also told in this question that y is inversely proportional to z squared. This means that we can write y is equal to some constant c over z squared. I've used the letter c here to differentiate from the k in the first one. Now we also have a pair of values here. We've got when y is 4, z is 3. So we can substitute those in. So instead of y equals, it's 4 equals, then it's c over, and then we have z squared, but we know z is 3, so it's 3 squared, which is 9. You can multiply both sides of this by 9, and you find that c is equal to 36. So we can replace the c in that top formula with 36. In the question, we've been asked to find the value of x when z is equal to square root 6. To do this, we're going to use both of these formulas here. Since we've been given the value of z, we'll start with the one on the right and substitute z for square root 6. So we have y equals 36 over, and then z squared, which is square root 6 squared. When you square root 6, you just get 6, so it's y equals 36 over 6, and 36 divided by 6 is 6. Now that we have the value of y, we can substitute this into the first formula. It says x equals 1/4 of y, but we know that y is 6, so it's 1/4 of 6, which is 1.5, and that's the answer to the question. In this question, we've been given a line. It has equation 6y equals 25 minus 9x, and we've also been told about the point A, which is on the line and has coordinates k, k. We've been asked to find the value of k. To do this, we're going to take the equation of the line and substitute in the coordinates of that point A. Since both of the coordinates are k, we can replace x and y with k. So instead of 6y, it's 6k, equals 25, and then instead of minus 9x, it's minus 9k. We can solve this equation to find the value of k. Let's add 9k to both sides. If you add 9k to the left, 6k plus 9k, that's 15k. And if you add 9k to the right, that'll cancel the negative 9k, so you've just got 25. Divide both sides by 15, and you'll find that k equals 25 over 15. You can simplify this, divide them both by 5, and you'll end up with 5 over 3. So the answer to this question is k is 5 over 3. In the second part of the question, we've been told about the coordinates of point B. They're 7.58, and there's a second line which is L2, and it's perpendicular to line L1 and goes through that point B. And we need to work out the equation of the line L2. To do this, we're going to go back to the line L1, that's this one here, and we're going to work out its gradient. To do this, we're going to write it in the form y equals mx plus c, so we need to get y as the subject. To do this, we'll divide both sides by 6. If you divide by 6 on the left-hand side, that'll give you y, and if you divide the right-hand side by 6, you can divide 25 by 6, which I'm just going to write as 25 over 6, and divide 9x by 6, so it's minus 9x over 6. 9 over 6 will simplify because 3 is a common factor there, so that's 3 over 2. And we can see from this the gradient is now negative 3 over 2. So the gradient of line L1 is negative 3 over 2. Now if L2 is perpendicular to this, its gradient must be the negative reciprocal of that. So the gradient will be positive rather than negative, and we do the reciprocal of 3 over 2, which is 2 over 3. So the gradient of the line L2 must be 2 over 3. Now we can write the equation of the line L2 as y equals 2/3 x, since we know that's the gradient, but we don't know the intercept yet, so we'll just write plus c. But we can find the intercept because we know the line L2 goes through this point here. So if we substitute in those values into the equation of the line, we'll be able to find the value of c. So the x-coordinate is 7.5 and the y-coordinate is 8. Let's replace y with 8, so 8 equals, and then replace x with 7.5, so 2/3 of 7.5 plus c. This will give you 8 equals, if you do 2/3 of 7.5, you get 5, so 5 plus c, and then subtract 5 from both sides, and you'll find that c is equal to 3. We can now replace c in the equation to give us the equation of the line L2, y equals 2/3 x plus 3. In this question we have an equation, and we've been asked to show this a solution between the values of 2 and 3. To do this, we're going to take the left-hand side of the equation, and we're going to substitute in 2, and then 3. So let's substitute in 2 first. So we need to do 2 cubed, subtract 2 lots of 2, subtract 6. This will give you the value negative 2. Then we'll do the same thing but with 3 instead. So 3 cubed, subtract 2 lots of 3, subtract 6. And this gives you 15. If you look at the two answers we got here, you can see one's negative and one's positive. So we've observed a change of sign. This is sufficient to show there's a solution here, since the equation has a solution when it equals 0. If we've gone from negative to positive, there must be a solution somewhere between the values of 2 and 3. For the second part of the question, we need to show that this equation here can be rearranged to give this one. So let's start with the equation, and let's carefully, one step at a time, manipulate it so it ends up with the other equation. Let's start by adding 2x to both sides. If we add 2x to the left-hand side, that'll cancel the 2x that's already there, so it's just x cubed minus 6. And if we add 2x to the right-hand side, 0 plus 2x is 2x. Now we're going to add 6 to both sides. That'll cancel the 6 on the left, so it's just x cubed, and then 2x plus 6 on the right. And finally, we cube root both sides. If you cube root x cubed, you get x. And if you cube root the right-hand side, you're just going to have to write this as the cube root of 2x plus 6, which is what we wanted to show. In the third part of this question, we've been given an initial value, x0 equals 2. And we've also been asked to use this iterative formula here 3 times to find an estimate to the solution of the equation. So we're going to start with our first value, x0 equals 2. We're then going to substitute this into the formula to work out the next value, which is x1. So x1 is going to equal, then we write down the formula, which is the cube root of 2xn plus 6, but I'm going to replace that xn with a bracket. And then inside that bracket, I put the previous value, which was x0, which was 2. If you type this into your calculator, you'll get this as the answer. Now to get x2, we do exactly the same process, but instead we put inside the bracket the previous number, which was this 2.1544 and so on. Now if that number's already on your screen, in reality you're probably not going to type that whole number out again, but replace that with the answer button. So you'll type the cube root of 2, bracket, answer, close bracket, plus 6. And if you press equals, you'll end up with this number here. We then do this one more time. Remember it said 3 times in the question. So to get x3, we do the cube root of 2 lots of this number, so 2.17 and so on. And once again, this number will already be on your screen, so you can use the answer button here. And if you type all of this into your calculator and press equals, you'll end up with this. So we've done it 3 times now, so this is our estimate to the solution of the equation. For the final part of this question, we've been asked to substitute the answer we got in part C into this expression here, and then comment on the accuracy. So what we're going to do is take this answer here from part C and substitute it into this, and see how close we get to 0. So if we do 2.179477396 cubed, subtract 2 lots of that number, and then subtract 6, using your calculator you'll get this number here, which is very, very close to 0, therefore it would be a pretty good solution. So if we're going to write a comment, we could write our solution is accurate, as this is close to 0. In this question, we've been given a histogram, and we need to work out how many students revise for more than 1 hour. Whenever you're working out a frequency from a histogram, we'll need to use this formula here. The frequency is equal to the frequency density multiplied by the class width. So if we're looking for students that revise for more than 1 hour, that's 60 minutes, we're looking for these students here. If we look at this bar, you can see its frequency density is 0.2 since it goes up just one little square, and its class width goes from 60 to 100, so that's 40. So we multiply the frequency density, which is 0.2, by the width of that bar, which is 40, and 0.2 times 40 is 8. So that bar is representing 8 people, so 8 people revise for more than 1 hour. For the second part of the question, we need to work out an estimate for the interquartile range of the time spent revising. To do this, we're going to work out how many people there are in total. So let's start with the first bar on the left. You can see the frequency density here is 4, and the class width goes from 0 to 20, so that's 20. So we do 4 times 20, which is 80. So there are 80 people represented in that first bar. Now let's repeat this for the next bar. The frequency density is 1.6, and its class width goes from 20 to 50, so that's 30. So if you do 1.6 multiplied by 30, there are 48 people in that bar. And now for the third bar, the frequency density is 10.4, and its class width from 50 to 60 is 10. 10.4 times 10 is 104. So there's 104 in that bar. And for the final bar, we've already done this, is 0.2 times 40, which was 8. So there's 8 in the final bar. If we add up all of these frequencies, we find there are 240 people in total. So if we want to find the interquartile range, we need the lower and upper quartiles. To find the lower quartile, we do 1/4 of 240, which gives you 60. This means the 60th person is representing the lower quartile. To do the upper quartile, we do 3/4 of 240, which gives you 180. So the 180th person will represent the upper quartile. The question now is, where are these people located? So what we want to do is start at the left-hand side and try and work out where the 60th person would be if we move from left to right. Well, we know they're going to be in the first bar since there are 80 people in the first bar. If you chop the first bar in half, there would be 40 people on either side of it. If you then looked at the right-hand side of this bar and chopped that in half as well, you'd split that 40 into two 20s. And if you add 40 and 20, you get 60, so we can see there'll be 60 people to the left of this line here. So if this is where the 60th person is, then this value here on the bottom axis represents our estimate for the lower quartile. That's halfway between 10 and 20, so we would say the lower quartile is equal to 15. Now we need to do the upper quartile. So this time we're going through 180 people. Well, if you add up these first two bars here, you get 128. So it's going to be past the first two bars. But how much more? Well, if we do 180 take away 128, we get 52. So we need 52 more people, which if you notice, that's exactly half of the next bar, since the bar is 104 and half of that is 52. So the person for the upper quartile will be located here. If we read off that value, we get an upper quartile of in between 50 and 60, that's 55. We can now work out the interquartile range by doing the upper quartile subtract the lower quartile, so 55 take 15, which gives you 40 minutes. In the first part of this question, we need to work out the length of the line AD. We're going to look closely at the triangle ABD, which is this one here. We're going to label each of the sides of the triangle, including labeling the one we're trying to find AD as A. So if we label AD as A and the other two as B and C. We then label the angle opposite each of those sides with the same letter but a capital, so like this. Now we can use the cosine rule to find the value of A. We would write A squared equals B squared plus C squared minus 2BC cos A. Now we substitute in any of the values we know. We don't know A, so that's A squared, but we do know B and C, so B squared plus C squared would be 12 squared plus 20 squared, and then minus 2BC, which is minus 2 times 12 times 20, and then multiplied by cos of A, where A is 30, so multiplied by cos of 30. If you type this whole right-hand side into your calculator, you'll end up with A squared equals this number here. To find the value of A, we now just square root both sides. This will give you A equals the square root of that number, and if you square root that using your calculator, you'll get this number here. The question asks us to round this one to one decimal place, so we should give the answer 11.3. In the second part of the question, we've been asked to work out the length of the line BC. Since this shape is a trapezium, the top and bottom lines there are parallel. If we draw on this Z shape here, you should be able to spot that angle BDC is also 30 degrees, since it's an alternate angle to the other angle that's 30 degrees, angle ABD. If we now look at the other triangle, triangle BCD, that's this one here, we can label up these sides in the same sort of way. We're going to label BC, the side we're trying to find, as A, the angle that's opposite this is capital A, the other side we're given, 20, that's going to be B, and the angle opposite that is capital B. We can now use the sine rule to find the value of A. So the sine rule is A over sine A is B over sine B. Let's substitute in the values we know. We know capital A, that's 30 degrees. We know little b, that's 20 centimeters. And we know capital B, that's 36 degrees. To find A, just multiply both sides by sine 30. That'll give you A equals 20 sine 30 over sine 36. Type this straight into your calculator and you'll get this answer here. And once again, rounded to one decimal place, gives you 17.0. In this question, we're trying to find the angle x. We're going to look at the triangle on the base of this cuboid here, triangle EGH. We know the line from G to H is 6 centimeters, you can see that on the diagram, and we can also work out that EH must be 8 centimeters, since it's the same as BC, which is marked as 8 centimeters. We can now use Pythagoras to find the length of EG. So EG squared must be 8 squared plus 6 squared. 8 squared add 6 squared is 100, so EG squared equals 100. Then if you square root both sides, you find that EG equals 10. So from E to G must be 10, let's pop this on the diagram. Now we're going to look at this triangle here, triangle ECG. We can tell the length from G to C is 20, and we just worked out the length from E to G is 10. And the angle we're trying to find x is down in the bottom left here. We can now find the angle x using trigonometry. If we label the sides, we've got from E to C, that's the hypotenuse, from C to G is opposite, and E to G is the adjacent. In this question, we're not going to need to use the hypotenuse since we don't have that information, so we're going to need to use O and A. If we write out SOHCAHTOA, O and A both appear in tan. So we can write tan of the angle, which is tan of x, is equal to the opposite, which is 20, divided by the adjacent, which is 10. If we now take inverse tan of both sides, we find that x is equal to the inverse tan of 20 over 10. Type this into your calculator and you'll get this number here, and this one wants us to round to 3 significant figures, so it would be 63.4. In this question, we've been told that v is equal to 3.5, and that's correct to one decimal place. And then r is equal to 0.08, correct to one significant figure. The first thing we're going to need to do in a question like this is write down the error intervals for v and r. Let's do the one for v first. So if v is 3.5 to one decimal place, its lower bound will be 3.45, and upper bound will be 3.55. Then we have r, which is 0.08, but correct to one significant figure. The lower bound will be 0.075, and the upper bound 0.085. Now we've been asked to work out the upper and lower bound for the value of a, and we have this formula for a, which is v squared over r. Let's start by talking about the upper bound. If we want to make a as big as possible, then we want to make v as big as possible, since that's the number on the top of the fraction here. So we would use the upper bound for v. But once we've done v squared, we're going to divide it by r. And if you're going to divide by something, if it's quite a big number, that'll make your number small. But if you divide by a small number, you'll make your answer big. So we want to divide by the smallest possible value for r. So for r, we're going to use the lower bound. So if we do v squared over r, but make sure we use the upper bound for v and the lower bound for r, we would do 3.55 squared, divide by 0.075. And that would give you this number here. Now let's do the lower bound. For the lower bound, it'll be the other way around. We'd want the lower bound for v and the upper bound for r. So if we do the lower bound for v but squared, that's 3.45 squared, divide by the upper bound for r, that's 0.085, we get this number here. So these are the upper and lower bounds for a must be somewhere in between these two values. So we just write those on the answer line, but we've been asked to give them to 6 significant figures. So the first one, upper bound, will be 168.033, and for the lower bound, 140.029. In this question, we have a and b, which are consecutive integers. If they're consecutive, it means they come after each other. So if we had the two numbers, a and b would be the number that comes after a, when you're counting, for example. Now if b comes immediately after a, it must be 1 more than a, so we could replace this b with an a plus 1. Now we've been asked to prove this statement here algebraically. What we're going to do is write that out, but every time we get to a b, we're going to write a plus 1 instead. So let's start with a cubed. plus AB, but b is a plus 1, plus b cubed, but b is a plus 1. So we need to show that this statement is an odd number. To do this, we're going to expand it all out. The a plus 1 cubed at the end is a plus 1 times by itself 3 times. So let's replace that with a plus 1, a plus 1, a plus 1. Now let's start doing some expanding. So at the front we've got a cubed, then if we expand the first bracket it's a times a, which is a squared, and then a times 1, which is just a. Then if we move on to the triple bracket, we're going to expand the first 2 of these brackets first, and then write that inside this bracket here, and then multiply by a plus 1. So if we expand that double bracket, we do a times a, which is a squared, we do a times 1, which is a, and then 1 plus a, which is also a, so there's 2a, and then 1 times 1, which is 1. Now we can move on and expand the triple bracket. So let's leave all of the first terms the same, a cubed plus a squared plus a, and then we would do a squared times a, which is a cubed, a squared times 1, which is a squared, 2a times a, which is 2a squared, 2a times 1, which is 2a, 1 times a, which is a, and 1 times 1, which is 1. Now we can do some simplifying by collecting up the like terms. We've got a cubed and a cubed, that's 2a cubed. We've got a squared, another a squared, and 2 more, so that's 4a squared. Then we've got a plus 2a plus a, that's 4a. And finally, plus 1. Now when you're trying to show that something's an odd number, it's usually easiest to show it's 1 more than an even number. So if we ignore this plus 1 on the end for the moment, but factorise a 2 out of the other terms, we'd get 2, then inside this bracket a cubed, plus 2a squared, plus 2a. And then we do have this plus 1 at the end. This section here must be an even number, since it's 2 times some number. It doesn't matter really what happens inside that bracket. I know it's going to be an integer, and when I double an integer, it's always going to be even. So we can conclude the proof now by saying that this is an even number, so this, which is the same thing plus 1, must be an odd number. In this question we need to solve an inequality. To do this we're going to pretend for the moment that it's not an inequality symbol, but an equal symbol. So imagine we were trying to solve this instead. You could solve this one by factorising. The only way to get 3x squared is having 3x and x, and the only way to get a negative 5 is if we've got a 5 and a 1, and one of them is going to be positive and one's going to be negative. So it doesn't take too long to try numbers and see that you can factorise it like this. This would give us 2 solutions, if it were an equation. We'd say 3x minus 5 equals 0, and also x plus 1 equals 0. The first of these, if you add 5 then divide by 3, gives you x equals 5/3, and the second one, take away 1 from both sides, x equals negative 1. These are known as the critical values for this inequality. If we imagine we drew a sketch of the graph 3x squared minus 2x minus 5, it would look something like this. We know it's going to cross the axis at these critical values. Then we need to consider, are we interested in the part of the graph that's above the x-axis or below the x-axis? Since we want 3x squared minus 2x minus 5 to be less than 0, we're interested in the part that's below the x-axis, which is this part here, since it gives values that are less than 0. So if we're interested in this part of the graph, what x values give you this section of the graph? Well, it's the x values that are in between these 2 critical values here. So we can write the inequality solution as x is in between the values of negative 1 and 5/3. And that's the solution to your inequality. If it were the other way round and we wanted a greater than, we need it in 2 separate parts. We need x to be less than negative 1 or x greater than 5/3. In this question we have shapes a, b and c that are similar. If shapes are similar, it means they're each a scale factor enlargement of the other ones. We're first of all going to look at the information we've been given about the heights. You can see the height of shape b is 18, and the height of shape c is 63. We can use this information to work out the scale factor enlargement between shape b and c. If we do 63 divided by 18, we end up with 3.5. This means all of the lengths of shape c are 3.5 times as long as they are for shape b. So the scale factor enlargement for the heights is 3.5. But this won't be the same as the scale factor enlargement for the surface area or the volumes. For the surface area, we would need to square the scale factor that we use for the heights. So this one will be 3.5 squared. And for the volume, we would cube the one we use for the height, so it'll be 3.5 cubed. Now this does mean we can find out the surface area of shape C by doing 720 multiplied by 3.5 squared. and that will give you 8,820, so we can put that into the table. We can't do anything with the volumes though, because we don't know the volume of shape B or shape C yet. Now let's look at shapes A and B. You can see we've got the surface area for both of them. So let's work out the scale factor enlargement for the surface areas. If you do 720 divided by 320, you can see it's 2.25 times as big. So the scale factor for the area is 2.25. We need to work out the corresponding scale factor for the height and the volume. Now remember earlier we said the scale factor for the area was the square of the scale factor for the height. So if we square root 2.25, we get 1.5. So we could rewrite that surface area scale factor as 1.5 squared. This would mean the height scale factor is 1.5, and the volume scale factor is 1.5 cubed. We now have all the information we need to fill in the missing blanks in the table. Let's work out the height of shape A first. So whatever this height is multiplied by 1.5 will give us 18. So if we do 18 divided by 1.5, we get 12, which is the height of shape A. Then if we look at the volumes, we've got the volume of shape A, that's 1152, and if we multiply it by 1.5 cubed, we'll find the volume of shape B, which is 3,888. And finally, if we take this volume and multiply it by 3.5 cubed, we get the volume of C, which is 166698. In this question, we have a triangle that has side lengths 9, 10, and 11 centimeters, so it will look something like this. We've been told some information about its angles A, B, and C. A is the smallest, then B, and then C is the largest. When you have a triangle like this, you can be sure that the smallest angle will be opposite the smallest side. So A must be opposite the 9, we must then have B opposite the 10, and the largest angle must be opposite the largest side, so C must be opposite the 11. Now we can label all of the sides as well as the angles. The side opposite each of the angles will be the same letter but in lowercase. So the 9 will be A, the 10 will be B, and the 11 would be C. We've been asked to show that cos of A is equal to 7 over 11, and we're not allowed a calculator for this one. If you write out the cosine rule for angles, it's cos of A is b squared plus c squared minus a squared over 2bc. So let's substitute in these numbers. So we have cos of A equals b squared, which is 10 squared, plus c squared, which is 11 squared, minus a squared, which is 9 squared, over 2 lots of bc, which is 10 times 11. So 2 times 10 times 11. Now let's work this out. Well, 10 squared, that's 100. 11 squared is 121. 9 squared is 81. And 2 times 10 times 11 is 220. On the top here, we can add 100 and 121, then subtract 81, and this will give us cos of A is equal to 140 over 220. There's a common factor of 140 and 220 of 20, so if you divide both of those by 20, you get 7 over 11, which is what we needed to show. In this question, we need to work out the sides of angle ABC, and we've been asked to give reasons for each stage of our working. Now there are a few different ways of doing this question, I'm just going to do one of them, but as long as you give very clear reasons, you'll be able to get all of the marks still. I'm going to mark on ABC, the angle we're looking for first, that's this red one here. Then if I mark on angle CDF, which is already there at 53 degrees, that's the same as this angle over here, angle DAC. We call this the alternate segment theorem. So angle DAC is also 53 degrees. So we're going to write this down and give reasons for it. So we would say that angle CDF is equal to angle DAC due to the alternate segment theorem. Next I'm going to look at this angle here. You can see this angle is inside a triangle and I have the other two angles, so I can just add those ones up, which gives me 137, and subtract this from 180, which gives me 43. So the blue angle here must be 43, and we need to explain that step, so we would say that angle CDA equals 43, because angles in a triangle add up to 180 degrees. We're now able to find the angle we're looking for, angle ABC. ABCD is a cyclic quadrilateral, since all 4 of the corners of that shape are on the circumference of the circle. There's a theorem that says the opposite angles in a cyclic quadrilateral must add to 180 degrees. So all we need to do is look for the angle that's opposite the one we're after, so that's the blue one, 43 degrees, and subtract this from 180. So 180 take away 43 is 137. And once again we'll explain this step, so we would say that angle ABC equals 137 degrees, and the reason is opposite angles in a cyclic quadrilateral add to make 180. So the answer to this question is 137. In the first part of this question, we need to describe a single transformation where points C and D are invariant, but points A and B are not. This means once we've done the transformation, points C and D will remain in exactly the same place, but points A and B are going to move. The only possible transformation that fits this description is if we reflect the shape in this line here. You can see points C and D are both on this line of reflection, therefore they won't move. The shape will look like this when it's reflected, and you can see that A and B do move. So we could describe this one as a reflection in the line y equals -2. For the second part of the question, we need to describe a transformation again, but this time it's only point B that's invariant. There's more than one option for this. Firstly, you could do any rotation of the shape as long as the centre of rotation is B and the angle you're going to rotate is not 360. So for example, we could do this rotation here. You can see point B remains in the same place, but all of the other ones move. So this is a rotation 90 degrees clockwise about the point -1, -1. So once again, any rotation is fine as long as the centre is -1, -1 and it doesn't go 360 degrees, or it'd go back to where it started. You could also do an enlargement. For example, if we enlarge the shape like this. This would be an enlargement, scale factor -2, centre -1, -1. So once again, this works because we've chosen the centre of enlargement to be the point B. This will work for any enlargement as long as the scale factor isn't 1. In this question, we need to solve an equation involving algebraic fractions. We're going to multiply the denominators of the fractions together to get a common multiple. So we would write both of these fractions again, but as over x plus 5, x minus 1. So on the left fraction, we had x on the numerator, but we've multiplied the denominator by x minus 1. So we must also multiply this x on the top by x minus 1. For the second fraction, we have a 2 on the top, but we've multiplied the denominator by x plus 5. So we multiply the 2 on the top by x plus 5 as well. And all of this is equal to -1. Now that we have the denominators the same, we can combine the fractions to have a common denominator. So we've got x bracket x minus 1, subtract 2 lots of x plus 5, and this equals -1. Now we're going to expand all of the brackets on this numerator here. So let's write everything else the same first. Then we would do x times x, which is x squared, x times -1, which is -x, -2 times x, -2x, and -2 times +5, -10. The -x and -2x would simplify to give -3x. And now what we're going to do is multiply both sides by both of these brackets here. If you multiply the left side by these brackets, they would cancel. So we've just got x squared minus 3x minus 10. And if we multiply the right hand side by those brackets, we've got -1 lots of those brackets. Now we're going to leave the left hand side alone, and we're going to expand that double bracket, but write the results inside a larger bracket. So we've got -1 lots of whatever those brackets give us when we multiply them out. So we do x times x, which is x squared, x times -1, -x, 5 times x, that's 5x, and 5 times -1, -5. Again, we can simplify the x terms here. -x plus 5x is plus 4x. Now we'll continue to leave the left hand side as it is, and on the right hand side we've got -1 lots of all of these terms. If we multiply those terms by -1, they'll remain exactly the same but a different sign. So the positive x squared becomes -x squared, the positive 4x becomes -4x, and the -5 becomes +5. Now let's take this and move it up to the top. We want to get all of the terms on the left hand side here and the right hand side to be equal to 0. So let's add x squared to both sides first. If you added x squared to the left, we'd now have 2x squared and minus 3x minus 10, and on the right hand side that'll cancel the x squared, so we only have -4x plus 5. Now we can add 4x to both sides. If we add 4x to the left, we've got 2x squared. We add 4x to that -3x, which is just plus 1x, and then minus 10. And on the right hand side, when you add 4x, that will cancel the -4x, so we have 5. Then we subtract 5 from both sides. This gives us 2x squared plus x minus 15 equals 0. Now that we've got the quadratic in this form, we can try and solve it. This one will actually factorise. It would be 2x minus 5, x plus 3 equals 0. And then we get two solutions. Either the first bracket is 0, so 2x minus 5 equals 0, or the second one is x plus 3 equals 0. To solve the left one, we add 5 to both sides first, so 2x equals 5, and then divide both sides by 2, x will equal 2.5. For the right one, subtract 3 from both sides, and you end up with x equals -3. So there are two solutions to this equation. X is 2.5, and x equals -3. In this question, we've been given some information about two ships, A and B, that are travelling directly to a port. We're going to try and draw a diagram of what's going on. So let's draw the port first and call that P. Then we need to try and draw the ships. If ship A is travelling on a bearing of 70 degrees, it must be somewhere over here on the left. Because when we then draw a north line at A, the angle this makes when we draw a line from A to P needs to be 70 degrees. Then we'll do the same thing for ship B, so ship B would be somewhere down here, since the angle this time when we draw a north line at B and then connect it up to P needs to be 20 degrees, so this angle in here is much smaller at 20 degrees. We're then told the distance from ship B to the port is 35, so we can add this onto our diagram as well. And the distance between ship A and B is 30, so if we connect up A and B with a straight line, this is 30. And we've been asked to find the bearing of ship B from ship A. So the bearing of ship B from ship A is the angle you would turn through if you were at ship A, facing north, and turn clockwise to face B. If you were at A and turn clockwise, you turn through that blue angle 70 degrees, but you'd have to keep going and turn through this red angle as well, and then you'd be facing B. So we just need to work out what this red angle is, then we can add it to the blue angle to get the answer. So how do we find this red angle? What we're going to do is draw a north line at P as well. All of the north lines are facing in the same direction, so they're parallel. So if we look at the north line that's at A and the north line that's at P, we have a set of co-interior angles, which must add to make 180. So if we draw this angle here, this must go with the blue angle to make 180. Since the blue angle is 70, this must be 110. We can now do the same process by looking at the north lines that are at B and P. So if we draw in this angle here, which is in purple, the blue angle is co-interior to the sum of the orange and the purple angles. So they must all add to make 180 degrees as well. So if we add 110 and 20, we get 130, which means there's 50 left to get to 180. So the purple angle here must be 50 degrees. We now have enough information to find the red angle. If we look at this triangle here, and we label the angle we're trying to find as capital A, the side opposite this could be lowercase a, the other angle in the question capital B, and the side opposite that lowercase b. We can now use the sine rule to find the value of capital A. So we could write sine of capital A over A is sine of capital B over B. Now let's substitute in the numbers. We know lowercase a is 35, capital B is 50, and lowercase b is 30. If we multiply both sides by 35, we get sine A on the left, and on the right 35 lots of sine 50 over 30. You can type this right hand bit into your calculator and it will give you this decimal here. Then to find the value of A, we do the inverse sine of this number, which comes out at this number here. So we found the value of the red angle now, it's about 63.3 degrees. If we add this to the blue angle, we get the answer to the question, so 70 plus 63.3 is 133.3 degrees. For the first part of this question, we need to find an estimate for the acceleration of the go-kart when t is equal to 10. We can find the acceleration of a speed-time graph by finding the gradient at that point. This graph is curved, however, so we're going to need to draw a tangent at the point when t equals 10. Now everyone will draw a slightly different tangent, but you want to draw a line that's straight that just touches the curve at the point when t is 10, so something that looks a little bit like this. Then we're going to draw a gradient triangle to try and work out this line's gradient. I'm going to draw quite a large one that looks like this, and then I'm going to work out the vertical and horizontal distances. Let's start with the horizontal distance first. You can see my triangle goes from 0 all the way to 16, so that's a distance of 16, and vertically it goes from 8 to 16, so that's a distance of 8. We now find the gradient by doing the change in y over the change in x. The change in y here is 8, the change in x is 16, so it's 8 over 16, which is exactly equal to 1/2. So the answer here is 0.5. Now you may get a slightly different answer here depending on which tangent you drew. As long as your answer is somewhere near to 0.5, you're probably going to be okay. For the second part of the question, we need to work out an estimate for the distance that the go-kart travels in the first 15 seconds, and we've been told to use 3 strips of equal width. Well, if it's the first 15 seconds and we need to split that into 3 equal strips, 15 divided by 3 is 5. So we need to draw a strip every 5 seconds. So if we draw lines that go up at 5, 10 and 15 like this, and then stop when they hit the curve, we can then connect up the tops of those points like this, and here's our 3 strips. The distance travelled is the area under this curve, so we're going to find the area of those 3 shapes. The first one here is a triangle, so we do 1/2 times the base, you can see the base is from 0 to 5, so that's 5, times the height, and you can see the height of this one is about 9. So 0.5 times 5 times 9 is 22.5. Now let's move on to the second strip. This one's a trapezium this time, so we're going to use the formula for the area of a trapezium, which is 1/2 times the sum of the parallel sides. Now the parallel sides are vertical on this trapezium, so we need to read those vertical distances. The one where the line goes up at 5 is 9, we just did that one before, and when it goes up at 10, that's at about 13. So it's the sum of 9 and 13, and then multiplied by the height. Now perhaps confusingly, the height of this trapezium is actually its width, at 5. If you type this into your calculator, you'll get the answer 55. Then we do the same idea for the final strip. This is a trapezium again. So it's 1/2 times the sum of the parallel sides. Again, the parallel sides are vertical. So it's the one that goes up from 10, and that's at 13, and the one that goes up at 15 goes to 14. So it's 13 plus 14, and then again times the height, which is the width of the strip, which is also 5. Type this into your calculator and you get 67.5. So all we need to do now is add up all of these areas. If you add all of that up, you'll end up with the answer 145 meters. The first thing we're going to do in this question is simplify square root 500. Square root 500 is the same as square root 100 times the square root of 5. We know the square root of 100, that's 10. So this is the same as 10 times root 5, or 10 root 5. So let's rewrite the question, but write 10 root 5 instead of the square root 500, like this. Now we're going to look at the denominator of this fraction. It's square root 5 plus 1. This question requires us to rationalize the denominator. So we're going to multiply the top and bottom of this fraction by that denominator, apart from we're going to change the sign from a +1 to a -1. So we multiply both the top and the bottom by root 5, subtract 1. To multiply these, you put each of the numerators and denominators in brackets like this, so 6 minus 10 root 5 times root 5 minus 1, and on the bottom, root 5 plus 1 times root 5 minus 1. And now we need to do some expanding. So let's start with 6 times root 5, which is 6 root 5, then 6 times -1, that's -6, -10 root 5 times root 5. To do this one, you times the root 5s together. Root 5 times root 5 is root 25, which is 5, and then times this by 10, so 50. But of course it's negative since one of the signs was negative, so -50. And finally, -10 root 5 times -1, we're multiplying two negatives so it becomes positive, so it's positive 10 root 5. On the bottom we have root 5 times root 5, which is 5. Root 5 times -1, that's negative root 5. 1 times root 5, that's positive root 5. And 1 times -1 is -1. Now we can do a bit of simplifying. We have 6 root 5 plus 10 root 5, which is 16 root 5. And we also have -6 subtract 50, which is -56. On the bottom we have 5 take away 1, which is 4. But we also have negative root 5 plus root 5, which gives 0. So those cancel out. All that's left to do now is divide this numerator by 4. So if we do 16 root 5, divide that by 4, that's 4 root 5. And -56 divided by 4, that's -14. You can now see it matches the form we were given at the top of the question, a root 5 minus b, where a and b are integers, so a would be 4 and b would be 14. In this question we need to find the coordinates of the turning point of the curve with this equation here. To do this, we're going to take the equation and we're going to complete the square on it. We're going to factorise 2 out of these first two terms here. So we'd have y equals 2 and then a bracket. Then inside this bracket we need x squared to get 2x squared, and we'd need plus 6x to get 12x. And then we've also still got this minus 7 at the end. What we're now going to do is focus on what's inside the square bracket here. So let's write everything else down the same, so y equals 2 bracket minus 7, and now we'll take what's inside that bracket and we're going to complete the square on that. So if we were to complete the square on this, it would be x in a bracket all squared. We would half the coefficient of x, so half of 6, which is 3. We would then square this number, so 3 squared, and subtract it, so subtract 9. So these two expressions here are equivalent. So we can replace the thing inside the square bracket with x plus 3 all squared minus 9. You can now expand that bracket back. So we're going to do 2 lots of that big bracket. So it's y equals, first of all, 2 times x plus 3 all squared, which is just 2 times x plus 3 all squared, then 2 times -9, which is -18, and then we have this -7 at the end. The final thing to do to complete the square here is just simplify these last two terms. So we have y equals 2 lots of x plus 3 all squared, and then -18 subtract 7 is -25. Now that it's in this form, we can find the coordinates of the turning point. The x-coordinate will be the opposite sign of this number here, so not positive 3 but negative 3, and the y-coordinate will be this one here, so negative 25. So the coordinates of the turning point of this graph are negative 3, negative 25. For this question, we need to do some simplifying of algebraic fractions. You'll notice the first two fractions are divided. When we divide fractions, we multiply by the reciprocal of the second fraction. So let's keep the first fraction the same, and change this divide to a multiply, but then take the reciprocal of the second fraction, so a bit like flipping it upside down. So the 6x squared minus 20x goes on the bottom, and the 5x squared minus 5 goes on the top. At the end it says plus 2x to the power negative 1, well x to the power negative 1 is 1 over x, so this is the same as 2 over x. Now we have loads of factorising to do. If you look at the first fraction on the numerator, you should spot we have a difference of 2 squares. That could be factorised as 3x plus 10, 3x minus 10. The square numbers are a dead giveaway there. On the bottom we can also factorise, and actually the brackets that are on the top give us a bit of a clue. So it's actually 3x plus 10 and x plus 1. Then we move to the second fraction. On the numerator we could factorise out of 5. So it's 5 lots of x squared minus 1. But x squared minus 1 is also a difference of 2 squares. It's x plus 1, x minus 1. So we could replace that with x plus 1, x minus 1. On the bottom we can factorise into a single bracket. We'd factorise out 2x, then inside would be 3x minus 10. And on the end we still have this plus 2 over x. We can now multiply these two fractions together to make one huge fraction. We'll just multiply both numerators and both denominators. So we're just going to have lots and lots of brackets. So the numerator will look like this, and the denominator will look like this, and we still have that plus 2 over x at the end. Now there's lots of cancelling that can be done. We can cancel these two brackets, and these two brackets, and also these two brackets. So all we're left with on the left fraction is just 5 bracket x minus 1 over 2x. So let's write that down, and plus 2 over x. On the numerator of that left fraction we can expand the bracket, so it's 5x minus 5 over 2x. And since we need to add these fractions together, let's make a common denominator by multiplying this second fraction by 2 on the top and the bottom. So we end up with 4 over 2x. We can now add them together. We end up with 5x minus 5 plus 4 over 2x. Negative 5 plus 4 is negative 1, so the final answer is 5x minus 1 over 2x. And you can see this matches the form they asked for in the question, ax plus b over c, where a, b and c are integers. So a would be 5, b is negative 1, and c is 2. In this question we have a graph that has this equation, and also a straight line that has this equation. And we've been asked to find the coordinates of the points of intersection. To do this, we're going to solve them as simultaneous equations. Let's take the second equation first, and rearrange it to get x as the subject. To do this, we can just add 3y to both sides. If you add 3y to the left, you get x, and if you add 3y to the right hand side, you get 4 plus 3y. Now we're going to take the first equation, but rewrite this, and instead of x, write 4 plus 3y, since x is equal to 4 plus 3y. So instead of x squared, it's 4 plus 3y squared, then it's minus y squared equals 48. This is now an equation in y that we can solve. If we look at the bracket that's been squared there, that just means times 4 plus 3y by itself, so 4 plus 3y times 4 plus 3y. Then we have minus y squared equals 48. Let's expand this double bracket. We do 4 times 4, which is 16, 4 times 3y, which is 12y, 3y times 4, which is 12y, and 3y times by 3y, which is 9y squared. Then we have minus y squared equals 48. We can do some simplifying on the left-hand side. We've got 9y squared minus 1y squared, which is 8y squared. 12y plus 12y is 24y. And then we also have plus 16 equals 48. Since this is a quadratic equation, we want the right-hand side to be equal to 0. So we subtract 48 from both the left and right. If you subtract 48 from the left, we get 8y squared plus 24y. And then we do 16 take away 48, which is negative 32. And this equals 0. We can now take this equation, and you can actually divide both sides by 8. You'll notice that 8, 24 and 32 are all multiples of 8. So if we divide the left-hand side by 8, we get y squared plus 3y minus 4, and if you divide 0 by 8, that's still 0. We can solve this one by factorising. It would be y plus 4, y minus 1 equals 0, which gives you two solutions. The first one is y equals negative 4, and the second one, y equals positive 1. Now remember, in this question we're looking for coordinates of points of intersection. So we have the y values of those coordinates, we need the corresponding x ones. To do this, you can substitute those y values back into one of our original equations, but probably the easiest one to use will be this one here, since x is the subject. So if we start with when y equals -4, then x will be 4 plus 3 lots of -4, which gives us -8. Then if we say that y is equal to 1, we need to do 4 plus 3 lots of 1, which is 7. So we're almost there, we just need to form these into coordinate pairs. When y was equal to -4, x was equal to -8. So the coordinate here will be when x is -8 and y is -4. We also had when y was equal to 1, x was equal to 7, so the coordinate here will be when x is 7 and y is 1. So we end up with two solutions. The first one is -8 with -4, and the second one is 7 with 1. For the first part of this question, we've been asked to draw the graph of y equals -f of x. If you already have the graph of f of x, -f of x will be that graph reflected in the x-axis. So we're going to take all of the key points of this graph and reflect them in the x-axis. Let's start with the one on the left. That's only one square above the x-axis, so if we reflect it, it will go one square below. The next one along is two squares up, so that will go two squares below. The next one is actually on the x-axis, so that won't move. Then the next one is one below the x-axis, so that will go one above. And the final one is two above, so it will go two below. Then you can join them up with straight lines, just like the original function, and it will look something like this. In the second part of the question, we have a curve and it has this equation here, and we're going to transform it by this vector here. This vector is telling us to go 3 to the left, and then 8 up. Let's consider this graph as a function. So f of x equals 7 minus 2x squared. If we're going to move this graph 3 units to the left, that's doing the function f of x plus 3. Whenever we move a function left or right, the number that we adjust it by goes inside this bracket, and it's also the opposite of what you might expect. If we move left, we actually put a plus 3. If we were to move right, we would put a -3. And then also we need to move this graph 8 up, so we would put plus 8, but this time it's in the y direction, so we put that outside of the bracket of the function. So we just need to work out what this function would be. To do f of x plus 3 in a bracket, you'd write out the same function as f of x, but replace all of the x's with x plus 3. So this is going to be equal to 7 minus 2 lots of a bracket squared. Inside that bracket will be x plus 3. And then we just have this plus 8 on the end. So all we need to do is expand this bracket out and simplify. So we have 7 minus 2 lots of this bracket squared. Let's square this bracket. Now remember, think of this as a double bracket, so it's x plus 3 times by itself. This will give you x squared plus 3x again, and then plus 9. And we also have this plus 8 right at the end. Now we can multiply through by -2, so we have 7 minus 2x squared minus 6x again, and minus 18, and then this plus 8 at the end. All we need to do now is simplify, and we probably reorder these to write the squared term first. So we'd have -2x squared, then we simplify the x terms, that's -12x, and then simplify the constant terms. So we have 7 subtract 18 plus 8, which gives you -3. So the answer to this question is -2x squared subtract 12x subtract 3. In this question, we've been asked to work out the equation of the line AC. To do this, we're first of all going to draw on the line from O to B, and then find its gradient. To find the gradient of the line OB, we can do the change in y over the change in x. This is quite easy for this one because one of the points is the origin. So to get from O to B, we would need to go 2 up, and then 5 across. So the gradient is 2 over 5. Now since the line AC is a tangent to the circle, we know a tangent meets a radius at 90 degrees. So we have a right angle here. This means the line OB and the line AC are perpendicular. When we have perpendicular lines, we can work out their gradients by doing the negative reciprocal. So the gradient of the line AC must be the negative reciprocal of 2 over 5, which is -5 over 2. So we now know the gradient of the line we're after, we just need its intercept. So we could write down its equation in the form y equals -5 over 2x plus c. To find the value of c, we're going to need to substitute in a point that's on the line. But we do know that point B is on this line, and its coordinates are 5, 2. So we're going to replace y with 2 and x with 5. So let's replace the y with 2, so 2 equals, and then replace the x with 5, so -5 over 2 lots of 5, plus c. So we have 2 equals, and then -5 over 2 times 5 is -12.5, and then plus c. If you add 12.5 to both sides, you end up with c being 14.5. So the equation of the line AC is y equals negative 5 over 2x plus 14.5. But the question requires us to give the answer in a very particular form, ax plus by equals c. It doesn't look like this form yet. Let's multiply both sides of this by 2 to get rid of that fraction. If we multiply the left by 2, we get 2y. Then if we multiply negative 5 over 2x by 2, we get negative 5x. And if you multiply 14.5 by 2, you get 29. If we now add 5x to both sides, we get 2y plus 5x equals 29, which is now in the form of the answer if we just switch the x and y terms round. We have 5x plus 2y equals 29. And you can see that's now in the form ax plus by equals c, where a, b, and c are integers. In the second part of this question, we're going to find the area of triangle AOC. That's this triangle here. To do this, we need to find the coordinates of points A and C. Now we already have the equation of the line going from A to C. That was in the previous part of the question. 5x plus 2y equals 29. So we know points A and C are both on this line. Now since A is on the y-axis, its x-coordinate must be 0. So if we say when x equals 0, and then substitute 0 into that equation of the line, we'd get 5 times 0, which is 0, and then plus 2y equals 29. So we get 2y equals 29, which you can solve to get y equals 14.5. This means the coordinates of this point A are 0, 14.5. We can do a very similar process to find the coordinates of point C, but this time, since it's on the x-axis, the y-coordinate must be 0. So we say when y equals 0, now if you substitute 0 in for y into that equation, you get 5x plus 0 equals 29. So 5x equals 29. Divide both sides by 5 and you'll find that x is 5.8. So the coordinates of point C are 5.80. We can now find the area of the triangle since we know the base must be 5.8 and the height must be 14.5. So the area is 1/2 times the base, which is 5.8, times the height, which is 14.5. Use your calculator to do this and you end up with 42.05. In this question, we've been asked to prove that these two angles here sum to make 90 degrees. There are many different ways of doing most proof questions. I'm just going to show you one way here. As long as your proof is fully explained and makes sense, you'll still be able to get all of the marks, even if it differs from this one. So I'm going to start by marking on this angle here, angle ACO, and I'm going to call it X. Then if I look at the lines OC and OA, they're both radii of this circle. Therefore, they must be the same length. So, if I look at triangle AOC, that's an isosceles triangle. So this angle over here must be the same size as x, so we can label that one as x as well. Now when we're doing a proof, we're going to need to explain all of the steps we do. So for this step, we could say OC equals OA as they're both radii, which means angle ACO equals angle AOC as they're both the base angles in an isosceles triangle. Next, we're going to use the fact that the lines OA and CB are parallel. If we draw on this Z shape here going across OA and CB, you can see we have a set of alternate angles. This means the angle BCA down in the bottom left must also be equal to x, since it's alternate to the angle OAC at the top. So we could say angle OAC equals angle ACB as alternate angles are equal. Next, we're going to add those two angles in the bottom left together to get a bigger angle which has size 2x. Then if we look at the line OB, this is also a radius of the circle, so it must have the same length as the line OC. So we can mark on this line to indicate they have the same length. And then we can also spot another isosceles triangle, the triangle OBC. This means this angle here must also be 2x. We can explain this by saying that OC equals OB, as they're both radii, and once again, angle OCB equals angle OBC, as they are base angles in an isosceles triangle. Now if we look at the third angle that's inside that triangle, the one up here, we could work that one out by adding the other two together and subtracting from 180. If you add the other two together, you get 2x plus 2x, which is 4x. So this one must be 180 take away 4x. We can explain that by saying the angle COB equals 180 minus 4x, as angles in a triangle add to make 180 degrees. Now the next part is possibly the hardest part to spot. If we draw on the chord from C to B here, this chord makes an angle at the centre of the circle. It's the one we just found, COB, which is 180 minus 4x. This chord also makes an angle at the circumference in the diagram though, this one here, the angle CAB. There's a circle theorem that says the angle at the circumference is half the angle at the centre. So if we half 180 minus 4x, we can find this angle here, which gives you 90 minus 2x. We should explain this step as well, so angle CAB equals 90 minus 2x, as the angle at the circumference is half of the angle at the centre. Now we've almost finished the proof. We're proving that the sum of angles BCO and CAB equals 90 degrees, and we actually have expressions for those two angles in the question. So the angle BCO is in the bottom left, that's 2x, and the angle CAB is the angle at the top we just found, 90 minus 2x. So if we add them together, angle BCO plus angle CAB, that must be equal to 2x, plus 90 minus 2x, and if you add those together, the 2x's cancel, so it gives you 90, and that concludes the proof. In this question, we're told the speed of a car n seconds after its brakes are applied is given by Sn. We're also told the car is travelling at a constant speed of 200 miles per hour. This means at the exact moment the brakes are applied, the car must be still travelling at 200 miles per hour. And we could say this is 0 seconds after the brakes have been applied, in which case we have S0. So S0 is equal to 200. We're also told in the question that the speed of the car falls by 54% in the first 2 seconds after the brakes have been applied. If it's after 2 seconds, then we would call this S2. And it's going to fall by 54%, but we know originally at S0 it's 200. So we just need to reduce 200 by 54%. You could do this by multiplying 200 by 0.46. And this will give you 92. So we know immediately as the brakes are applied, the car's travelling at 200, that's S0, and then 2 seconds later, which is S2, the car is travelling at 92 miles per hour. We're then told the speed of the car n plus 1 seconds after those brakes have been applied is Sn plus 1, and then we're given this formula here. This is an iterative formula that we can use to work out the speed of the car at any point if we know the previous one. So for instance, if we were trying to work out S1, we would substitute the previous value S0 into this formula. So that would be 0.8 lots of S0 minus k. Now we actually know what S0 is, we wrote that down at the top, it's 200. So we could say that S1 is equal to 0.8 lots of 200 minus k. We could expand this bracket, you get S1 equals 0.8 times 200 is 160, and then 0.8 times negative k is negative 0.8k. We could then do the same process to find S2 using the value for S1. So we would say that S2 is equal to 0.8 lots of the previous value, which is S1, minus k. Now whilst we don't have the numerical value for S1, we do have it in terms of k. It's 160 minus 0.8k. So let's replace S1 with this. So we have S2 equals 0.8 lots of S1, which is 160 minus 0.8k, minus k. We can simplify the k terms inside this bracket, so we get S2 equals 0.8 lots of 160 minus 1.8k, and then we can expand this bracket as well. So S2 equals 0.8 times 160, that's 128, and then 0.8 times negative 1.8k, that's negative 1.44k. But earlier on in the question, we worked out a numerical value for S2, it was 92. So we could replace the S2 with 92 and say that 92 is equal to 128 minus 1.44k. Now we can solve this equation to find the value of k. If you subtract 128 from both sides, you get negative 36 equals negative 1.44k, and then divide both sides by negative 1.44, and you'll find that k is equal to 25. The question has asked us to work out the speed of the car 3 seconds after the brakes were applied, so this will be S3. So we can write that S3 is equal to 0.8 lots of the previous value, which is S2, minus k. But we now know the value of S2 and the value of k. So we'd say S3 equals 0.8 lots of S2, which is 92, subtract k, which is 25. You can type this into your calculator and you'll get 53.6, which is the answer to the question. For the first part of this question, we need to find the vector AD in terms of A and B. To get from A to D, you could go from A to C first, and then from C to D. If we go from A to C, we're going in the opposite direction of that vector 3b, so we can change its sign to minus 3b. And then to get from C to D, we go in the same direction as that vector A, so it's plus A. In the second part of the question, we've been given lots of information about the lines and points in the question, and we've been asked to work out the value of k. We're going to start by looking at this ratio here, of AB to CD to EF. Let's mark on those lines. Now you can see that we know the vector for one of those lines, the vector CD. So if we write out the ratio, and then write the vector for CD underneath the middle part of the ratio, so underneath the 3, and that's A, we can use this ratio to work out the other two vectors in terms of A. To get from 3 to 4, you would divide by 3 and then multiply by 4. So we could say that the vector AB is 4/3 of A. To get from 3 to 17, you divide by 3 and multiply by 17. So we could say the vector EF is 17/3 of A. Let's add these onto our diagram. So A to B is 4/3 A, and E to F is 17/3 A. Now we're going to look at the part where it says BD is parallel to CE. Let's work out the vector BD. To get from B to D, we could go from B to A, then we could go from A to C, and then from C to D. And we know all three of those vectors. So BA is the opposite direction of AB, which was 4/3 A, so that's minus 4/3 A. A to C is the opposite direction of that vector 3B, so negative 3B, and then C to D is that vector A again, so plus A. We can simplify these two since they're in A. Minus 4/3 A plus A is minus 1/3 A. So minus 1/3 A minus 3B. So that's the vector from B to D. Let's put this onto our diagram as well. Now if the vector CE is parallel to this one, then the vector CE must be some multiple of that vector from B to D. We don't know what multiple it is, so I'm just going to call that n. So it's n lots of the vector negative 3rd A minus 3B, which was the vector BD. Now we're going to look at these next two parts. ADF is a straight line, and AD to DF is in the ratio 1 to k. If AD and DF are on a straight line, then we can be sure that AD and DF are also parallel, in which case DF is some multiple of AD. We found the vector AD in the first part of the question. AD was equal to negative 3b plus A. So we just need to work out the vector DF, which is going to be some multiple of the vector AD. Now we actually know what this multiple is. In the question we're told the ratio of AD to DF is 1 to k. This means the vector DF is k times as big as the vector AD. So we can write DF equals k lots of the vector AD, negative 3b plus A. Now we could also work out the vector from D to F in a different way. We could go the long way round, which is from D to C, then from C to E, and then from E to F. And we have all of those vectors as well. So from D to C is the opposite direction of that vector A, so minus A. From C to E is that complicated one, n lots of negative 1/3 A subtract B. And then from E to F is 17/3 of A. So we have two ways of writing down the vector DF, this way and this way. But since they represent the same vector, they must be equal to each other. So we could write this vector is equal to this vector. Let's expand out the brackets. So we have k lots of negative 3b, that's negative 3kb, and then k lots of a, so plus ka, equals negative a. And now let's expand this bracket too. So this would give you negative n over 3a, and then negative 3nb, and then we have this plus 17 over 3a at the end. Now since these two vectors are equal, we must have the same amount of a's and the same amount of b's on each side. Let's first of all look at the a's. On the left-hand side, I have k's. And on the right-hand side, I have negative a, subtract n over 3a, and also plus 17 over 3a. So if there are the same amount of a's on each side, then I could write that k must be equal to negative 1 minus n over 3 plus 17 over 3. We can tidy this one up a little bit by multiplying both sides by 3. We'd get 3k equals negative 3, subtract n plus 17. And then the negative 3 plus 17 will give me 14. Now let's do a similar process with the b's. On the left-hand side I have negative 3kb, and on the right-hand side negative 3nb. This would mean that negative 3k must be the same as negative 3n. If you divide both sides by negative 3, you get k equals n. So k and n are actually going to have the same value. So if I look at this formula here that I got from the a's, I could replace the n there with a k. So it's 3k equals 14 minus k. We can now solve this equation to find the value of k. If we add k to both sides, we get 4k equals 14, and then divide both sides by 4, we get k as 3.5. And this is the answer to the question. Thank you for watching this video. If you found it useful, please give it a like. Check out the video I think you should watch next, and subscribe so you don't miss out on future videos.